సార్ ఒకసారి మీ మైక్ చెక్ చేయండి సార్.
హలో సార్, am I audible?
వస్తుంది సార్.
Okay, thank you. నేను Okay, good afternoon all. I request all the Sparks, please arrange your students peacefully so that everybody can understand the nitty-gritties of the quantum technologies. Today, we will be having industry connect people who are working on the actual quantum technologies. One is Sujay Chakravarti from Confluence Private Limited, who has a long experience in quantum technologies and he is the founder. And another one is Rishikesh Ubale. He is also a quantum research software engineer. And also Rakesh Yata is also a quantum research software engineer. They will be dealing the technical sessions today. And meanwhile, I appreciate all our regional coordinators, right from Gayatri Vidya Parishad, College of Engineering, Visakhapatnam, Dr. Anuradha Madam. And I also appreciate the efforts of Dr. Ravikiran Varma Garu from SRKR Engineering College, Bhimavaram. I appreciate the efforts and the work done by Dr. Madhukanti Ravi Garu from the Nekula Institute of Engineering and Technology, Vijayawada. I appreciate Professor A. Shobhabindu Madam from JNTU Anantapuram. And I also appreciate and thank Dr. J. Suryakumar Garu from Padmavati Sri Padmavati Mahila Vishwavidyalaya Tirupati. So these are doing wonderful work and they are coordinating with their concerned district colleges. So each of the Sparks, the regional Sparks, they have entrusted with 3 to 4 districts, world districts. And I request them also to coordinate for the wide publicity. Today, it will be another momentous moment. Today's valedictory address, our chairman, Sir Professor K. Madhumurthy Garu, will be joining for this valedictory address. And my good friend also, Professor Vishnu Garu, a professor from mechanical engineering. He is part of this quantum hackathons. And Rajendra is also, who is actually doing all the web work, is also joining us. And my team, Srikanth is also there. We are actually doing from this AppShare. As you all know, this is a great opportunity for all the youngsters. I can promise all of you that if you are willing to travel in this journey, in this quantum journey, quantum valley journey, that is definitely you will be landing in the Amaravati Quantum Valley. You need not go to the Silicon Valley at America. So almost we are competing with other top industries, top countries also in terms of this quantum technologies. Very shortly, you will experience this momentous journey in your life. So once again, I congratulate all the participants, particularly the students, who have shown very interest and enthusiasm to work on this quantum computing and quantum technology and quantum algorithms. Please develop a passion towards this technology. This is a new technology. Of course, it is not very new, but the science is old, the technology is new. So you have to understand the science, you have to connect with the technology. I also appreciate all the mentors and spokes from various colleges, universities, not only from Andhra Pradesh and other states, so many states they have joined. And every day we are getting some requests from other states also to open this portal. That is one reason to give ample opportunity for all the students across India. We kept open this portal. That's why maybe you are getting some inconvenience in the updation of the information. So our aim is to involve as many as students they can participate, because the demand in Amaravati itself is 1 lakh students by the January 2026. So this is the demand. So to give you all an opportunity, we have included not only the engineering colleges, we also included all professional colleges, including the general colleges like BA, BCom, BSc students also, and faculty also. As I said, we are APSHA is parallelly doing the faculty development program. Almost 1,000 faculty are getting training on quantum technologies. And now we are aiming to train at least 50,000 students by this January. Maybe in valedictory, our Honorable Chairman APSHA, Professor K. Madhumurthy Garu, will give you so many SOPs. So what APSHA want to give to students? So he will address you and he will promise you so many things. And kindly stay tuned till the valedictory address of our chairman. This is the background, and once again, I thank all the mentors and spokes for your energy, your patience, your time given to this very important movement of quantum. Our state, Amaravati, particularly, want to become a quantum state in the near future. I think they're all connected, and please spread this message to other friends also. We have shared YouTube link also. And I request you, all the mentors and all the folks, please share this YouTube link only after the session is over, because it will disturb others also, because some of the students, they may play this YouTube during this listening. And here is another, my friend Rajender. He is actually the backbone of this. He is doing all the website work, all the portal work. So there are every day there are so much of demand is there. Every day, every minute he is updating. So with this small team, we are planning a mega event like this. Maybe with this scale, this I think it is India's biggest event. And at every level, you will get some appreciation from Chairman APSHA, and you will get also participation certificates for every. That's why I requested the spokes to give correct details of the students. His full name, his WhatsApp number, his institution name, his correct email ID, so that we can share the participation certificate to each and every participant here. And not only that, he want to give some other SOPs to all the participants as well as the mentors. Now may I request today's resource person. The first resource person is Sujay Chakravarti ji. Sir, are you there?
Yeah, I'm here.
Yeah, I welcome you, sir. Kindly unmute yourself, your video.
Yeah, I'm here. Can you hear me?
I am audible, but your video is not on, I think. Yeah, sir.
Ah,
I welcome you, sir. Just I would like to introduce you, sir, to our audience. Sir, here more than 20,000 students are there.
oh,
And
okay.
at every college, we have mentors and single point of contact faculty members are there. Particularly from AP, most of the students, they are very enthusiastic. They are participating eagerly. And not only that, sir, across India, there are some students from Tamil Nadu, Telangana, Maharashtra, Punjab, Rajasthan, Karnataka, etc. They are also there. So I welcome the participants from other states across India. So here is a brief about Sujay Chakravarti ji, today's resource person, and he's actually working in this quantum technology. He's an industry man. So Sujay Chakravarti is a techno entrepreneur with over 25 years of experience building cutting edge technology, ventures across semiconductor design, embedded systems, and quantum hardware. An electronics engineer by training, he is the co-founder and CEO of Confluence Private Limited, a quantum computing startup that is developing a photonics-based quantum computer in Bangalore. The company has also developed a coherent icing machine tailored for quantum-inspired solutions to near-term industrial optimization problems. Before Confluence, Sujay was the founder and CEO of Silicon and Beyond, a deep tech company focused on advanced high-speed SerDes IP, which was successfully acquired. His background spans chip-to-cloud system architecture, advanced signal processing, and hardware-software co-design.
Hello.
Yes, please. Capabilities he is now applying to accelerate practical quantum computing. At Confluence, Sujay focus on technology implementation, GTM, industry, and investor relationships. A strong advocate of applied innovation and ecosystem collaboration, Sujay is committed to pushing quantum technology from the lab to commercial reality. Sir, I welcome you and thanks for all. Thanks to you, in spite of your busy schedule, you are here to educate all our students and educate all our faculty members on the nitty-gritties of quantum technology and quantum computing. Thank you very much, sir. Now the floor is open for you.
Thank you. Yeah, so it's very good to see such a large gathering of people invested in quantum.
Kindly, I request.
Sujay sir, can you please unmute yourself now?
Yeah.
Sujay sir?
Yes, can you hear me now?
Yeah, yes, sir.
Okay. So yeah, good to see such a large gathering of students, and I welcome all of them. And it's also good to see so much focus on quantum technologies. It used to be a very small field, but it's rapidly growing. So it is what I find really good about this entire Andhra Pradesh initiative is how big the dream is, right? And I think all good things start with a big dream. We also are a company where we believe in dreams, and that is how we started doing quantum hardware when without knowing the sources of funding, etc., because we believe that we will be able to build really great technology. What I'm going to do is I'm going to share a presentation, and we will talk about this hackathon and my thoughts about the hackathon, how you should approach it, and I will also go kind of problem by problem, giving few of my thoughts. Not going to take a very large amount of your time. So let me just share a presentation to get started. Can you see my screen?
Yeah, it is sharing, sir, but not at visible.
Okay, it says it's paused. Okay, I'm going to just try resharing. Give me a second. Okay, can you see it now?
Yes, sir.
Okay, so I'm just going to spend a very small amount of time describing what we do. So it sets some context on what exists uh, out there in the world, and uh, the background that we come from, and why we are so interested in having a large number of students participate in such things. So at Confluence, we have two main products, right? We also have a lot of smaller products which are quantum in nature, which are used for very specific tasks. But the main products are two. This is the first main product. It is a full stack universal quantum computer. It will be able to solve all quantum computing problems when it is ready. But this is not ready. It's going to take 3 or 4 years. The reason why this is going to take some time is because we are doing some greenfield research on this. So we are starting from scratch, developing all the technology in-house, and it's based on photonics, which is not which is not what you see in the chandeliers or in the IBM machines. So it's a different approach. We believe in this approach. We believe that this approach will give scalable results. And this is a completely grounds up development which is happening in our country. And we are pretty happy to go down that route. So at the same time, we also have a second product. This product is actually available right now, right? It's not a fully quantum product, it's a quantum inspired product. What do you mean by quantum inspired products, right? We will discuss that as we go along. And in a lot of your problem statements, there are problem statements which use the NISQ philosophy. So you don't really need a quantum computer, but you need all these techniques which are inspired by quantum, right? So this is an Ising machine. It loads and solves qubits in parallel, and it does that using some natural phenomenon, etc. And the answer from this is a quantum-like improvement, right? So it improves speed by a factor of 1,000 and so on. It solves problems which cannot be solved on classical computers. Rishikesh, who will address you later, his company, for example, uses machines like this to solve a lot of the problem statements that they have. So I went and looked at the problem statements that were put out for this hackathon. And this is a very impressive list. Firstly, I will uh, commend whoever came up with this list. It covers length and breadth of several quantum topics. So a very good list, very challenging list, right? And I'm going to give some general gyan on what happens when something like this happens, or a hackathon like this is run, and there are so many topics here, right? So as students, you'll be very confused. So I think some people are drawing on the screen. Maybe you should avoid doing that. Uh, the green lines and yellow lines. So try not to draw on the screen. Yeah. So as students, you look at this and you're like very confused, right? What to do? And I was a student a long time ago. So the first thing that you will probably jump at is, what is the thing which is hottest, right? Market में क्या चल रहा है? And say that, okay, I want to do that. So everybody might look at this and say, the hottest thing is QKD. I'm not saying that, but you might think
Sir,
that,
can you please disable annotation for others, which is available for your screen sharing option? Disable
okay,
annotation
you want me to do something?
for others.
Advanced sharing options.
We do it your end, sir.
Uh,
Whenever sharing that there are available some more options where you
yeah,
can see annotation disable for others.
okay. Wow, there's a lot of annotations happening.
You
I
can
request,
reshare your.
I
You can
request all
reshare.
tutors and sparks, please control your students. They are writing something. Can you control them?
Can I show that, sir?
Yeah, you can please show where it is because I don't see it. I see advanced sharing options, but not.
You please stop your share.
Yeah, I will
Your
just stop my share. Yeah.
Sir, otherwise you can share your PPT to me. We present from here.
No, it's better if
No,
I presented.
sir, here I'm sharing Bootcamp
Right.
flyer. So
Yeah.
there we can see more options in right side whenever you share. So there spotlight this below the spotlight this share. You can see disable annotation for others. So
Okay.
this option will available for whenever you share, sir.
Okay, let me try to share again.
Right, sir. Please share once again your
Yeah, I am doing that.
presentation. Yes.
Disable annotations for others. There you go.
Presentation. Yes.
Okay. You're able to see my screen again?
Yes, sir. Yes, yes. There you can see more option at
I have
right hand,
done
sir.
this. I've done it. We're okay.
Right, sir.
Okay. So sorry, coming back to my chain of thought. And so I was saying that the first thing that as a student you usually will do, right, is you'll find what is the hottest topic and say maybe you've heard of QKD and people are saying that QKD is a great thing to do. And you will get like 100 entries for QKD and nobody will pick any of the other things. Uh, what I think we should realize is that what you have heard and what you think is the hottest topic today may not be the hottest topic tomorrow, right? So how do you go about it? I think my first advice to you is pick a topic which you have a reasonable understanding of, right? If you don't understand a QKD system and the deadline is a week from now, or the deadline is 2 months from now, or the deadline is 6 months from now, you're not going to be able to do a great job because learning something like that is going to take you a lot of time, right? Or if you don't understand how an optimization problem is solved or what a VQC is, that may not be the right problem to fix. So all these problems are good. All these problems are interesting. And I don't think that the winner is going to be based on what problem you chose. The winner is going to be based on how well you tackled the problem. So pick something which you understand to a reasonable degree. There is, of course, whatever you pick, you're going to have to do learning because you're going to have to go into the depths. So you're going to refer to your books, you're going to refer to the internet, you're going to refer to ChatGPT. So absolutely no problem. Do that, but pick something which you at least basically understand, right? Where you have a little bit of idea of what this topic is. And so that's on picking the topic. So that's how I would pick this topic. Maybe when I was a student, I would not do it that way. But the good thing being done here is you're listening to advice from people who have made their mistakes. So pick a topic which you understand. That's advice number one. Advice number two that I have, and where all of us go wrong, right, including companies like us, is you have to put yourself in the shoes of the end user. So what do I mean by that, right? It's very easy and sometimes very yeah. What we do is we develop something for ourselves. This is what I like. This is how I think I like to see it. And I know these 10 concepts, so why should I even bother with those 10 concepts? Let me directly skip to this 11th thing, something that I don't know. And I think that, wow, I've developed a beautiful product. And there are no users for this product, right? Sometimes you'll develop a beautiful, I'll take an easy example, which all of us understand. You'll develop a beautiful YouTube video and you'll love that video. You'll say, oh, what a beautiful job I've done, right? And you show it to 10 people and they look at it and say, I have no idea what you're saying. And that is because you have not put yourself in the shoes of that end user, right? So who's the end user here? Let's say the judge. So you have to put yourself in the shoes of someone who's judging it or someone who's using it, or you're building a product here. What will that end user think? So think about it from that point of view, that what is it that end users like? Right? And there are certain things which end users always like. One is that a good user interface, right? So the UI UX, it has to be something which the end user can relate to. The other thing is good explanations. When you understand what is going on, right? Or at least there is an intent to explain what is going on. So put yourself in the shoes of the end user. There are 100 other things which you will automatically come up across because you are also the end user on many things. You're the end user on a lot of really not so nice hardware/software that companies like us put out there also. So you can feel the pain. So try to think of that when you develop these solutions or when you solve these problems. And uh, coming to the next point, what I would say is make it easy to use and make it easy to understand. We are all guilty sometimes of complicating things, because you might think that if it's super complex, it will win. No, the things which win you've seen everywhere, even in life, right? I mean, the reason the iPhone became so popular is how easy it was, not because of how complicated it was. The tech is secondary. It's uh, keep it easy, keep it understandable. That helps provide all the relevant explanations. If there are pop-ups saying what is going on, that is also a good thing. And most importantly, right? Uh, the first thing that any of you will do when you pick a problem is you will go to ChatGPT and you will type the problem statement into ChatGPT and see what the answer is, right? So if you take that answer and you put it out there, the answer may be correct, but you're not going to win this challenge because what is unique, right? Or what is different? So I think what I would encourage you to do is think outside the box. Think of what differentiation you can add, what uniqueness you can add. Because with today's world of AI, the fact that you have the knowledge or the fact that you gather the knowledge is not going to win you this quiz. The fact that you wrote the code is not going to win you this quiz. If you just go put something like, use VQE to estimate ground energy of a molecule like hydrogen into ChatGPT, it will give you the code. I guarantee you, it will give you a code and it will run. But the challenge is not about how uh, you can get the code out, right? The challenge is about, your thinking, how you're thinking out of the box. What are you doing differently? How are you making the end user understand what is going on? How easy it is for him to understand, to use your tech. So do that. Think outside the box. Use ChatGPT by all means, but understand what it is giving you and understand what is your contribution to this entire scenario. Right. What I'll go do is I'll probably go like little one by one through these, give you a little bit of my take on this, and if I can add anything, not a lot. This is too much theory, too much tech. I obviously no one person can understand all of this. So let's see what these problem statements are, right? Quantum random number generator. This is a very interesting one, when I speak to a lot of people in industry, one of the things that they tell me is that the only use of a quantum computer today is as a quantum random number generator, right? I think none of us actually even thought about it, but quantum computer can be used as a quantum QRNG, and there are companies which are built on that, right? And here it says hardware/software. So think of what approaches are better, why a hardware approach is better, or is a software approach good enough? Uh, so do all of that work, right? And there is something called verifiability on a quantum random number generator. So how do you verify that it is really quantum random, right? So just think of these angles. If you decide to pick this problem, it's a very interesting field, but it's a field where you'll always be challenged about, are you quantum random? Are you safe? And for this, there are a lot of commercial designs available. So you can go look at what people are doing, right? People are making a lot of money on this tech already. So go look at it, go see what people are doing. Interestingly, Confluence has a quantum random number generator. Uh, it is available as a product if you want. And what we do is we use vacuum noise to do a QRNG. I'm not going to tell you how. I'm just going to leave it at this, saying, you can do a quantum random number from vacuum fluctuations, because vacuum fluctuations are quantum in nature, right? So think about it. It's pretty useful. And whoever picks this, I hope you come up with good solutions. QKD, I think this is the hardest of the lot, but the way this problem is worded is very clever or very interesting, right? It says QKD demonstration simulator, right? So they don't want you to do a QKD. It would be a very, very hard problem, I think. But a simulator would be a very interesting idea. So how would you build a simulator, right? I would think that it's more of a software kind of a project where you build a simulator. And having this beautiful working models where you can add noises and you can like disrupt links, you can have somebody snooping into Alice and Bob's communication and show why that doesn't work. I think that would be a very neat touch. This is something which you can build some really cool stuff around on the simulator, where you can pick a person, start making him snoop on your link, and then you show that the quantumness is broken, and immediately Bob figures out that it is broken. So I think as a simulator, this could be a very, very interesting project to pick. And it's going to be about how well you demonstrate how QKD happens, and what are the built-in protections for QKD. Quantum state visualizer. Okay. If anybody of you picks this and does a good job, I will offer you an internship or a job. So this is complicated. That's what that's what I feel. And I'm really looking at people who can help with this. So I know that as a student, one of the things you're always looking for is internships and jobs. So pick this, do a good job. And I hope the judges will then tell us who did a good job, and we would be very happy to talk to you. Decoding superdense coding. Okay, this looks like a very easy problem if you look at it uh, just off the bat, right? Without thinking about it in details. But like I said right in the beginning, think outside the box, right? And then you suddenly start seeing very interesting things you can do, right? Because there are real life effects, there are intricacies which affect this, you know. So can you put that into the system? Can you show what happens in the real life, right? Can you show what happens with noise? Can you show what happens with poor channels, right? Can you show what happens if there's an error in a decode or something like that, right? So doing this in a simulator would be a very interesting thing. I think this is a very good pick because it's a simple enough problem, but you can demonstrate a lot of very fascinating things by picking something like this. So I think a good problem to pick. Quantum chemistry, this is VQE. VQE is very interesting, right? I mean, when you think about it, this is one of these NISQ era problems, and you have to make up your mind whether this NISQ era or noisy quantum computing will work and whether it does anything useful or not, right? The jury is out there. Uh, People keep saying that VQE will probably never outperform classical, but it's still an interesting problem to try. Uh, there are VQ has a lot of optimizations also, non-quantum stuff going on. So can you do some very interesting things in the non-quantum stuff, right? Can you use interesting optimizers, right? Uh, can you get to a better solution? It's an interesting problem to try for that. And the molecule that they have given here is a small enough molecule. It has been shown to be solved using VQE. But getting it down to the lowest power is an interesting challenge. Yeah. I don't know if you guys have access to a real quantum computer. You would need that as well to do something like this. I hope you do have that access. Quantum jobs tracker. This is not a quantum project. So, so it would be. I don't know if someone who picks this is going to win this contest because what you've been told to do is build a dashboard from a known source. But let me tell you what jobs I have open in Confluence. So please send me applications if you are a software developer look for the quantum classical hybrid layer, an RTL design engineer, or any other bright quantum candidates, right? But I really fear that this may not be the winning entry. I've gone and put all the other ones together because for me, right, they form a uh, bunch of algorithms which are kind of quantum inspired, right? Not they don't really need a real quantum computer, and that's probably why they are more real life. When I say real life, that's because there are industrial applications of these things. And uh, you will hear from others also that the quantum software industry, which is worth billions of dollars, uh, is being run on these real life things. They don't need a fully functional error corrected universal quantum computer, right? You could get around the errors using some tricks, or you could use a quantum inspired method, or they work on computers which don't necessarily hold quantum state. So non-error corrected, noisy computers or quantum inspired machines can be used for all of this, right? Uh, the use case statements are very clear what algorithms should be used for which one, right? They've very clearly said use this algorithm for this other algorithm for this, machine learning for something else. So maybe if you deviate from what they've asked, you may not get marks for it. But you are always allowed to be creative about how you do the classical pieces of it, right? How you do the quantum inspired pieces of it. So do that. Figure out, how you. That's where you get most of your creativity from. Because if they fix the algorithm, then what you do on a quantum computer becomes fixed. But what do you do outside of that is still open to interpretation, right? So Confluence, for example, use the product 2 which I showed you, which is a coherent Ising machine. It can solve all of these problems, right? You need to create a cubo, which is a very standardized way of coding a problem, and you can actually run it on that machine, and it'll be able to solve it. You can check out our website to figure out some of this stuff, how it is done, how to get access to a machine like ours, etc. But just saying that there are various ways that you can do this, right? Uh, you can go to YouTube and Google Confluence. You will find some very interesting videos there. You will actually find some videos which show some of these problems being solved. So by a machine. So just for getting some ideas, you might want to go there, look up at the channel, and so on and so forth. But these are all very real, very good problem statements to have. How you demonstrate how these problems are being solved, how you're getting the minimum energies, what you compare against. All of these, I think, are factors in this. But again, these are real life problems. You will get real life solutions. You might even get solutions which are deployable in the field somewhere or the other. So, good set of problems to pick if you are more into real life applications and so on and so forth. So, overall, fairly diverse problem statements, very nicely created. And I think this will be a very, very interesting challenge for all the students. And I will encourage you to, again, go with that flow which I spoke about. Pick something which you understand reasonably well. think about the end user, think about who's going to use the problem, who's going to use the final solution, how do you make it easy for them to use, easy to understand what you're doing. Keep it simple. The solution should be simple, because that is what finally works best. And at the end of it, the winner is going to be someone who comes up with this brilliant idea out of the box, right? Problem statements have been very clearly defined, so you can't like suddenly do something different from this, right? If they say that use VQE, you have to use VQE, but what you do out of the box in doing this is probably what is going to win this contest. So that's my take on this. This is whatever little advice I could offer to you. I will wish all of you the very best and good luck at doing this. And again, I'm thrilled to see so many participants, so many students interested in quantum, and ANDHRA doing such a big hackathon. Well done, sir.
Thank you, sir, for your sparing time. Actually, we want to encourage all the students. That's why we keep some very easy and very basic level problem statements. Some are at mid level, but some of the companies like you, they are laughing at some very easiest. But our aim is to encourage all the students to rope into this quantum movement.
No, sir, I don't think I'm laughing at this at all. These are very complicated problem statements.
Yeah. We kept some complicated, but some very basic.
No, I was only the number 6, right? It's a dashboard. There's nothing quantum in there, so I was just making a joke, sir. I was not laughing at
Sir,
very well built.
Sir, I thank you very much for offering internships. So actually, it is one of the criteria we have set for the winners from semi-final onwards. So we will select some of the students. We will send for internships. Even if your requirement is there, even we send to conference also.
Okay.
So this is the offer from our AppShare side. And for some of the winners also who can produce the use cases, even they will get jobs even at Amaravati Valley itself.
Okay, very good. That's
a
very good initiative.
Yeah, this is the beauty of the outcome of this hackathon.
Yes. Thank you, sir. Thank you very much for holding the hackathon and inviting me to share my thoughts.
Yeah, thank you, sir. We will be in touch with you even for the further progress of our students, like internships, etc., even for jobs at your startup company.
Yeah. Thank you so much.
Thank you. I think one or two questions from students or mentors.
Yeah, absolutely.
Yeah, please, the floor is open for the mentors or students. Please, if you have any queries, please ask. I think it is very lively and it is a very interesting session where the expert is speaking to students directly. Any of the mentor or any students from any college, one or two, we can give one or two opportunities. Anyone from any college? Yeah, Uday Kiran, Sri Satsai Institute of Higher Learning, please. You can speak, sir. You are unmute. Sir, Dr. Uday Kiran, sir. Sir, you can speak. You can unmute your mic.
I think he's typed out saying that the host needs to unmute him.
Yeah.
Now participants can unmute yourself, please.
Yeah, I hope I'm audible.
Yes, I can hear you.
Yeah, so my question is basically, let's say for the internal hackathon, I come up with a particular solution and let's say hypothetically I get selected for the semi-final, but then let's say in between I have a better idea and I want to improve on the solution. So is it compulsory that I present whatever idea that I have presented in the internal hackathon to the semi-final, or can I actually improve it on the go and I can present it on that particular problem?
I think Akshay would be the people who can comment on that. I would encourage you to improve it, but the rules of the game are not decided by me. So you have to unmute yourself, sir.
Hello, sir.
So am I audible now? From
Yes.
one minute, madam. One minute. Everybody can improve their versions from internal hackathon to semi-finals and even semi-final to final. It is there. You can go on improvement. You can go on improvement. Yeah.
Hello, sir.
Yeah, please, one by one, please.
Sir, Sri Vishnu Engineering College
Sir, I'm
one of the
Nagarjuna
doubts, sir.
from.
Yeah, please, Sri Vishnu, please speak.
Sir, we are working on the second idea, that is the QKD simulator. So in the PPT that you have shown, you mentioned to display some neat models to add some touch to the. So models in the sense, are you referring to any?
అది కూడా ఆస్కర్ అవార్డు తెలిసిన అలెజాండో గారి డైరెక్షన్ లో రాబోయే మూవీకి అలెజాండో గారి తీపై ఒక మూల ఒక రోల్ కోసం పాత రోజులు గారిని కన్సల్ట్ అయ్యారట.
Sir, please follow online etiquettes, please. Please, everybody mute yourself. Only the speaker has to unmute the mic.
So working models in the sense, are you referring to any hardware? I mean, the hardware representation, sir. So because
Yeah, it might be very difficult for you to use hardware, but you can always model the hardware, right? So that's what I meant, that the channel or whatever, you should model those instead of using a perfect channel or a perfect communication link or a perfect system. You should model some of these hardware inaccuracies which happen in real systems. That's what will give you that extra advantage. That's what
yes, sir. Actually, we actually thought of doing that, but again, we've thought about the cost constraint, because if we do any models to present, would it be cost effective for us, sir, as we are students still?
It will be software models. So you can model the hardware in software. That's what I meant. It does not need to be a real hardware.
Okay. Thank you, sir.
Thanks.
Good afternoon, sir.
Hello, sir. May I answer the question? This is Dr. Ranjan Balajain from Mumbai. Sir, we are having holidays from 26th to 1st for Ganpati. So, am I audible, sir?
You are audible, madam. Please proceed.
Yes, sir. My question, I am Dr. Ranjan Balajain from Mumbai. My question is that, sir, we are having holidays from 26th up to 1st September in Mumbai for Ganpati, 5 days holiday. So we cannot keep internal hackathon on 29th. Can we prepone it?
Yes, madam, you can prepone.
Yeah.
And after second, you can submit.
Okay.
Sir, MG, sir, MG.
You are
On
allowed.
second, we can submit the report.
Yes, please submit.
Okay, thank you, sir. Thank you so much. Okay.
Good afternoon, sir.
Good afternoon.
We have selected quantum job tracker as a problem statement. What to do regarding to that? Is it?
Yeah, I think that is very straightforward. You build a interface which goes and looks at IBM's website and pull the jobs and display it in a nice fashion.
Hi, Sujay. Rishi here.
Yeah.
From Q Christie Quantum. So I was thinking for that sixth problem, even I suggested to Dr. Kumar that it is not a quantum problem. We need to change it. And I was thinking that why can we change it with something like a quantum machine learning task, like heart disease detection, a binary classification task, which should be a little bit simpler as well, but can give what we can say an actual quantum problem to the students. What do you think on this? Am I audible?
Yeah, you are. But again, this is for Akshay to decide.
Yeah. So Akshay will definitely decide that. But we can give our views, I think.
Yes, sir, we can do, but we want to encourage for some of the students who are very basic and who are not actually from engineering background. Of course, we can change it. If it is really your concern, we can change. No issues, sir.
Yeah.
Okay, thank you. So any one or two participants, please.
Sir, good morning, sir.
Hello, sir.
Good afternoon, sir.
Okay.
Please proceed. Please proceed.
Sir, I'm from Madanapalli Sri Gnanambika Degree College, sir. Sir, I select third question, sir, that quantum visualization. So, who will be the end of the user, sir? Is a trainer or else a student, sir?
Okay.
I think it'll be a student. My best guess is that it'll be a student who's going to be the end user or something like that.
Yes, sir. I have a small doubts about that, sir. The student may have some of knowledge about it or else nothing knowledge about it, sir.
Yeah.
Sir, if a student have some knowledge, we will continue from intermediate level. If that student didn't have any knowledge about it, we will come from the scrap of the topics that which we are going to display in our application. Is it okay, sir?
Yeah, it's perfectly fine.
Okay, sir. Thank you.
Thanks.
Thank you, sir.
Good afternoon, sir. Sir, am I audible?
Yes.
Sir,
Good afternoon, sir.
thank you so much for giving this opportunity, sir. Sir, this is Sai Lokeshwar from Mother Teresa Institute of Technology from Palamade. And my question is, sir, our team has taken the third one, which is a quantum state visualizer. But given the context, there is only so much we can simulate in a regular device. Like the number of qubits, as the number of qubits gets increased, computational process will also be exponentially hard. So, if I bring you a solution, what will you look in that as a end product?
I don't think the number of qubits matters. Even if you build a 5 qubit, 4 qubit, 3 qubit, it's fine. No one's going to be looking at that. What we are going to be probably looking at is what you have done differently, what you have done which is not available out of the internet, and how you have put the entire concept together. So I don't think people are going to say that, hey, you didn't build a 40 qubit simulator, because you don't have those NVIDIA machines needed to build that kind of stuff, right?
Yes. Sir. Thank you so much.
Anyone is there? Otherwise, we can invite another research
Hello,
person.
sir.
Please.
Hello, sir.
Yeah, please.
Sir, I am from Aditya Degree College for Women from Kakinada. And regarding the second problem statement, QKD demonstration simulator, could you please recommend us the best simulator to use?
No, I would not be able to do that. I think it is more like you have to build your own simulator rather than using a direct simulator. I think that's what the problem statement is. But again, see, the point here is not for me to give you recommendations on do this, do that, or use this simulator, this software. You guys are the best suited to do that. What we can do here is just give you advice on how you would approach it, what people look for, and so on and so forth. So I wouldn't be able to give you advice on which simulator to use for that.
Thank you, sir.
Thank you.
Good afternoon, sir. We are from Aditya University. The problem statement 9, that is identifying anomalies in transaction data using QML.
University, sir.
Will you please explain that problem statement? And my query is we need to identify the anomalies in the transaction. That means in online transactions, like in UPI transactions or in
Yeah, yeah.
ATMs.
Yeah.
In
I mean,
which way? That means in messages or
think of it as this thing, right? That let's say there's a credit card payments happening, and there are hundreds of credit card payments happening, right? So sometimes when you do a credit card transaction, you get a call saying this is a call from the bank's transaction monitoring team. So that is because they think that this might be a fraudulent transaction or this might be an anomalous transaction. So how do they find it? So there are methods of finding outliers or finding anomalies in bulk data, right? There are classical methods of doing it. There are quantum methods of doing it. So this is more like that there's a lot of transactions of some sort. You decide what sort. Okay, you might think that that's somebody's bank account, and an anomaly might be that this is probably a vada pav seller whose transactions are all 100, 500 rupees, 600 rupees, and suddenly there is a 1 lakh transaction, right? So that's an anomaly. But how do you detect something like that? It's you can do it in a quantum way. So that is what this problem statement is. I hope that explains.
Sir, a small doubt, sir. So, hello. Good afternoon, sir.
Yeah.
Hello.
Yes, good afternoon. Go ahead.
We are from the Institute of Technology, sir. I have a small doubt. As you said that quantum state visualizer, the problem statement, right, sir? Sir,
Sir, I request.
as we are implementing it, is there any works for that, like any certifications or internships you will provide, sir? We are implementing a third problem statement, sir.
Yeah, you are based in Bangalore, right next to our office, right? So, yeah, I think the idea is very clear. You need to win this challenge. You need to get to the semifinals, finals, and sir will definitely connect you with people who will provide the internship. So, the first step is to do well in this challenge, and every step comes after that.
Sir, good afternoon, sir.
Yeah, good afternoon.
I'm Omkar from Aditya Degree College. Sir, the five teams we should register, no, sir. Hello?
Yeah, go ahead, please. Yeah.
Sir, the five teams we have to register, no, sir, from our college. The five teams should be selected after internal hackathon or no? Before we should register.
I have no idea. Sir, Akshay, if you can clarify.
Hello, sir.
Yeah, you can register. You can register. You can
Hello.
register. You can register.
We can register after internal hackathon or before
No,
internal
before
hackathon?
before hackathon, before internal hackathon.
Before hackathon only we can register, sir?
Yes.
Okay,
Yes.
okay. Then what should we do with the shortlisted candidates of internal hackathon?
That is another aspect. We will share you. Everything is on the web portal. Statements. Okay. You please refer to our website. Sir, I request.
Hello.
I earnestly request all the participants, please mute yourself.
Hello.
Yes, madam. Yes, madam.
Hello.
Yes, madam.
Yeah, sir, namaste. I'm Professor Lalita Bhaskar from Andhra University. Sir, Mr. Sujay Chakravarti, I have a question from the student side. Apart from IBM, do we have any other company or sources where there is real hardware implementation of quantum technologies? Like
Yeah.
where students can really go and work on qubits?
Yeah. So this is a very loaded question. Okay. The first
Hello?
part of the question,
Hello?
can you hear me?
Yeah.
Yeah. So this is a very heavy question. The first part that I would like to clarify is you said quantum technologies. Okay. Quantum technologies is a very vast field. It's not just computing. Okay, I'm getting
Sir,
an
MG
echo.
sir.
Please mute
Hello,
yourself.
sir. Am I audible, sir?
Yeah, you're audible.
Gabbar Singh, I was trying to answer.
Sir, I want to know that about sixth question, sir.
Yeah, can you hold on while I answer the question?
Yeah. Sure. Okay, sure, sir.
Yeah. So quantum technologies is a very wide field. It includes communication, material, sensors, and there's a lot of real hardware in all of these fields. Okay. So your students can have access to a lot of quantum hardware, even from companies in India, including us. If you're referring to computing, that's a slightly different question. Right? Qubits, the real quantum computers. How many companies in the world have it? It's not a very short list. There's probably 8 or 10, right? And a lot of this is actually available online. You can go through AWS, etc., and access some of these computers. So the computers are available. IBM's computer is available. Interesting that there is also an Indian company called QPi AI who has a real quantum computer, right? So these computers are available. Ours is not right now. A computer in our technology is also not commercially available. There are a few companies worldwide working towards it. But many of these other companies do have machines which are accessible, and the ANDHRA Quantum Valley can definitely make some of this accessible to students now or in the near future.
Thank you very much for your input.
Hello, sir.
Yes.
Sir, am I audible?
Yes.
So I'm Padu from BBC College of Engineering. I have a question about.
Bro, please wait, bro. I'm asking question na.
Bro, please 1 minute.
No 1 minute, bro. Why 1 minute, bro? Why are you interfering, bro? I am also asking sir permission, bro.
Okay, guys, behave yourselves. This is not your college, so please go one by one and do not say things which are not.
Sir. Hello, sir.
Yes.
Sir, I'm Padu from BBC College of Engineering. I have a doubt on quantum state visualizer. Is there any existing app or tool on a quantum state visualizer, or can we create a new one according to our project?
I would encourage you to create a new one.
How, sir? How can we create a new one?
I don't think this is the this is the right forum for that. I think that's where your guides and professors and all come in. So you should discuss this more with them.
Very nice.
I request all the mentors and spokes, please control your students. Only one is allowed. The two, they have to behave like a student decently. It is a very serious program where we would like to encourage all the students to be the stakeholders in the coming AMARAVATHI Quantum Valley. So don't behave like that. Once again, I apologize our resource person for this behavior. Thank you very much. I think you will understand.
Okay.
Thank you very much, sir, for your patience and your encouragement. And you made this event very easy by saying that so many problem statements are not tough and some are easy, some are maybe one or two is very tough. So this gives us a very pleasant occasion, and maybe our students will also inspire and get connected with this, and they will also get entangled with quantum nature.
Hope so.
Yeah.
Very much. Thank you for inviting me, and good luck to everyone. Do well on the challenge. Thank you.
Thank you, sir. Thank you.
Thank you, sir. Sir, thank you, sir. Sir, have a nice day, sir.
Sir, excuse me, sir. Hello.
Yeah. No.
Yes, sir. Get it right. Sir.
I request, it's appeal from my side, from APSHA side. Please be very composed and very cool. And one by one, we have to ask. So many discussing internally. There are so much of disturbance. You are free to behave like anything, but you please maintain the online etiquettes. Please mute your mic and mute your videos during the time. Okay. So I would like to invite the next speaker. Very important. Two speakers are there, I think. Sir Rishikesh Ubaliji, are you there?
Yeah, I'm there.
Yeah, you are welcome, sir. And also I request Rakesh Yata. Are you there, sir?
Yes, sir. I am there.
Thank you for your honoring this request. And on behalf of AP State Council of Higher Education, we welcome you, sir. And I thank you very much for your sparing your valuable time. So would like to invite you. It is here a brief about Rishikesh Ubale. He is a quantum research software engineer with hands-on experience in quantum optimization, machine learning, and algorithm design. He published across finance, fraud detection, and industrial systems, skilled in QUBO modeling, hybrid quantum classical systems, and benchmarking quantum algorithms against classical baselines. He is passionate about translating theoretical insights into a scalable, real-world quantum applications. His education is from Raja Rambabu Institute of Technology, Shivaji University, BTech, and Mechatronics Engineering. He is a bright student having a scholarship with a tuition fee waiver from merit-based scholarships awarded by the Government of India to top performers in the MHCET State Engineering Entrance Examinations. So his work experience is QKrishi Quantum, that is a research software engineer. It is a startup company. He developed a quantum classical hybrid LSTM model for credit card fraud detection, achieving significant improvements in training speed, epoch, and perfect recall as adaptations and qubit scaled, tested up to 12 qubits. So he is an expert as on today, maximum qubits he has experienced. At AMARAVATHI, we are getting 156 qubit. So he achieved an inference time of 4.2 milliseconds per transaction, making the model viable for real-time detection systems. The solution is currently under active evaluation by banking institutions. There are so many other achievements for him. He heads aerodynamic systems at Space Club RIT and Shivam Bosch Pump Services, and so many publications and invited talks. And I would like to also introduce another resource person for today's. These two are experts in actual handling of these problem statements. And I also invite Rakesh Yata. His work experience is as a research software engineer, QKrishi. His research on quantum-powered solutions for finance, implementation of hybrid quantum algorithms, identifying potential use cases across industries, collaboration with academicians, industry professionals to create useful quantum solutions with the current quantum technology. He is a quantum researcher and developer of QBrid AI. So he carried out research on optimization for finance and used quantum annealing technology by D-Wave for implementation and mathematical understanding and formulation of optimization problem, research on quantum machine learning use case, that is synthetic data, mimicking a distribution by using QGNs, worked with NVIDIA, Q quantum appliance, benchmarked the performance of GPUs, CPUs, and which got QU quantum appliance on them. Supported QBrid AI platform, development to identify bugs and issues related to quantum software package, organized testing by external researchers on QBrid AI platforms. There are so many other initiatives by these two gentlemen. These are very young, maybe they will connect to you, all the students, because the latest technology is for youngsters mostly. Now, sir, the floor is open. I invite you all. Before they are taking this session, once again, I appeal all the participants, particularly the mentors and sparks, please control your students. It is very serious session going on, and more than 20,000 students across India, they have joined now. So any disturbance will disturb them, because some of the students and some of the mentors are very seriously involved in this very important quantum mission. So I once again an appeal from our side. So let the speakers speak first, and immediately after their sessions is closed, we will open for question and answer. Till then, we will mute you all. And even question and answer sessions will be allowed one by one. Only one student, when one mentor or student speaking. Others, I request, please follow the internet online etiquettes, and you have to mute your video, your audio especially. Video, we don't bother about video. You can open video, but mute your audio, because it is causing so much of disturbance. And some people, they are speaking very casually. If such cases, such candidates, you can leave this very important online session. We are not bothered about such fellows. If you want to chit chat with your neighbors, you can leave this very important conference and very important online session. With this, I request both Rishikesh Ubale and Rakesh Yata. They are actually deeply involved in these problem statements also. So you can one by one, they will explain very deeply, very intricately, and they will handhold you. and they will definitely clarify all your doubts. But you please be patient, and one by one you have to follow very religiously. This is my appeal. Now the floor is open for you, sir. Please welcome. You can, Rishikesh ji and Rakesh ji, please.
Thank you, Apshi, for this wonderful introduction and all. Can you allow Yasser Mulani to share? He's sharing this presentation from our team.
Sir, can you spell it, sir?
Yasser Mulani. Yasser, can you raise your hand?
Yeah. Yes, sir.
Yeah. Please. Narayan, please mute all except the three.
Yes, sir.
Yasser, when you are.
Sir, can you unmute yourself, sir, please?
Yes, I have the access. Just a minute. I'm sharing. Please let me know if it's visible.
Yes, sir. It is visible.
Yeah. So, hello everyone. I'm Rishikesh Dubai. You got my introduction from Apshi. And today I'll be teaching you few core concepts, giving a brief introduction about quantum and how you can relate these core concepts and map it to the hackathon problem statements. So let's start from the very beginning. Yes, sir, put the next slide, please. Yeah. So let's start. Like quantum computing is nothing new. Now you might be hearing this is the quantum year. What we can say. Everything is going on. Like Bangalore announced its quantum city. You saw the event of AMARAVATHI Quantum Valley, and there are a lot of sessions, webinars, and everything going about quantum. But it's not something that started, in the recent years. It is going on from decades. So, if you have this your classnet notebooks, you have heard about this ENAC computer, the very first which take a room. So it came to the practice at 1940s and 50s, and it is very simple computer who was taking a huge space, which was able to do only a few computations. And then after that, you got the Moore's law. In 1965, that the transistor doubling every 2 years, the size is getting small and smaller into the atomic level, and we are now able to shrink that big ENIAC today in the laptops that you're holding in your hand. So after that, in 1981, Richard Feynman, the Nobel laureate in quantum chromodynamics, said that nature is not classical, it is quantum, and to simulate nature, we need quantum computers. In 1994, Shor's algorithm, a large integer factoring algorithm, came into place, and it showed us mathematically that it could break RSA, the encryption methods that you are using in your emails and all. And in 2001, the experimental demonstration of the Shor algorithm has been done. So it means that when the potential scale will happen, your emails, your what we can say encrypted with RSA security, your emails and other things will be not secure. They can decrypt it, they can read it. So quantum is scale. That's why people are getting too much attention to the quantum. Not only this other aspect, but the security aspect is the beginning. That's why all the countries are putting their efforts to become the quantum nations. Then D-Wave launched its first commercial quantum annealer. D-Wave is an optimizer, like another like Confluence. So these are some sort of icing machines which solve optimization problems. And in 2019, Google showed its quantum supremacy on a certain specific task, where it showed how it is more what we can say overpowering the classical methods. And now in 2021 to 2024, IBM, IonQ, Rigetti, which is also partnering with Fujitsu, Quantinuum, are providing cloud-based platforms and scaling their machines over 100 qubits plus 100 plus qubits. Yeah, go to next slide, Yasa. Hello. Yeah. So, yeah, why do we need quantum computing? As I said, Moore's law is slowing down. Now it is on atomic scale. even when you do such what we can say, increase the cores, the layers in your chips and all, it is going like at one point the saturation level will reach. And currently even the supercomputers are not able to solve that efficiently the NP hard problems, complex problems. And even for example, simulating the molecules with just 50 items is requires more memory. Combine all what we can say, lot of supercomputers with huge RAM, huge memory. Still, they are not able to solve such kind of problems. And quantum computer could break, as I mentioned, the RSA, EEG kind of encryption methods, classical encryption methods very quickly. So coming the security aspect, problem solving everywhere, classical has its limitations, and quantum computing is the new potential player here to solve such kind of problems, considering all the aspects. So what are the unique advantages of quantum? That is superposition, entanglement, and interference. Okay, and we'll explore one by one what are these, and where we can apply these to solve real world problems. Yeah. Next slide, please, Yasa. Hello. Next slide, Yasa. Yeah. So yeah, so today we are in the NISQ era, as Sujan was saying, that is noisy intermediate scale quantum era, where the hardware is quite noisy. So let's say you are 50, 100 qubits, but these qubits are very noisy. They are prone to error like decoherence. Let's say there's a superconducting quantum qubit, so there is cryogenic errors and other errors like temperature, which are causing the errors in the computation. So we are, it is estimated that till 2030 to 2035, it is what we can say that this error will be sought out and will escape this quantum era, and then we'll be able to efficiently solve these problems. So the focus areas are currently we are going to quantum in the industries are optimizations, logistics, finance, material simulation like molecules, which are most of the research institutes are taking up, quantum communication, security, QKD test beds and all, and quantum machine learning research, of course. So after this 5 years, when will have logical qubits which are error corrected qubits, will scale this what we can say will able to fully use the quantum powers. Let's see that how it scales up. But the estimated time, what we can say, the estimated time is 10 years, nearly by 2035. This is just estimation by Google, Microsoft, and such big companies. So yeah, next slide, please. Yes, sir. Yeah. So in this hackathon, what you guys need to do? So here, it is very hard to understand that like qubits, superposition, entanglement, and all kind of things. But you don't need to do any new physics. Okay, you don't need to invent any physics. You don't need to do such intricate tasks or such hard tasks. You just need to focus on application. Okay, hardware is not required. You just need to do simulations of the hardware. There are libraries like Qiskit, Pennylen, and like if you're doing optimization, you can what we can say, you can use some QoS, simulated annealing and all. So you don't need to do any such the hardware, because this simulation mimics hardware, because here you do this kind of problem solving, you do use the simulators kind of thing, and then you test it on hardware, because hardware is of course come with a high cost. Okay, so what you need to do is problem formulation is the key. Whatever your problem is, define it properly in your own words, do your research. Okay, keep the points on the stage, do the problem formulation, map it how you are going to solve it, and then leverage the existing frameworks like, as I said, Qiskit, Pennylen, D-Wave. These are for optimizations and all. And then what we can say, present your solution, what unique you are doing, what are the, like, you have the tools. I'll repeat, like, everybody will have the tools. You'll have chat gpt, you'll have open ais and other kind of things, but the beauty of it is the solution is how you put them together. Okay. Yeah. Yeah, sir, next slide, please. Yeah. So let's start with the core concepts. What is qubits? Okay. So as you know, classical bits are what we can say just 0 and 1. Let's imagine a coin flipping. Okay. So either it's 0 heads or tails. Okay. But imagine when the coin is getting like the coin is spinning. Okay. So at that time, while spinning, it's just not heads or tails. It is in the air. Okay, that is we can that is what we can call a superposition. Okay, so this is what we can say while spinning. Uh, okay, only when the coin lands you are able to observe it. That is called what we can say measurement. Okay, I'll just give a simple analogy again. So when you are seeing the coin lying down, you will see one side of it, that is heads or tails, which is 1 or 0. But when the coin is spinning, it is simultaneously 0 and 1. That is the principle of superposition. We'll see it in practice when you'll have these coding examples. So mathematically, we write is at ket, the what we can say, the diagrams you are seeing with the certain arrows and modular signs. That is psi ket alpha ket 0 plus beta ket 1. So these alpha and betas are the probabilities of ket 0 and ket 1. Imagine this ket 0 as tails and ket 1 as heads. So this alpha square and beta square always have a probability of 1. Can you get to the next slide here? Yeah. Yeah, go ahead. One more slide. I think I explained 2 of them. Yeah. Go to the quantum RNG. Next slide. Yeah. Yes. So here, as you're seeing, you're the very first problem of your hackathon, that is quantum random number generator. Okay. So how will you solve this problem? So you'll start with the qubit, what we can say, get 0. You'll apply the Hadamard gates. We'll cover this Hadamard gate one by one. So what is this gate? This allows you to, what we can say, take your coin into the superposition or take your data into the superposition. And then when then is superposition, you measure it. Okay. So once you measure it, either it can be 0 or 1. Okay, so this is complete random. Okay, and let's say for example, the example I have given you is 1,000 shots, which means I run this simulation for 1,000 times and I got it like one time. The heads, let's say head is 1, so 1 is 503 times we got heads, and 0 is like 597. Oh, sorry, 497 we got zeros. So it is like 50% of outcome each time. So why this is matter? If you are a machine learning, what we can say, machine learning engineer, or you know about a machine learning, there is something you can set up everything in random. Okay, random bits and all. So why this is important or why this matters? Because machine learning things are like, if you know the seed of it, you can reverse the process. You can always predict what they are. But when you use this kind of randomness, this can be used for cryptography. Let's say you are creating this 1,000 big strings. So it is random. Only you and receiver knows. The hacker or the viewer in the internet cannot know this kind of thing. Okay, so even this is because of its true randomness, it cannot decode. That's why this is a good problem statement, and this is important one. Quantum random number generator. Okay, so after that, scroll down. Yes, sir, for entanglement. Yeah. Yeah. So entanglement. So basically, there is a good story here on entanglement. So what it is? Entanglement is a special correlation between qubits. Okay, as I said, like qubits simultaneously they are 1 and 0. But when you take the classical bit, like a switch on and off, either it is 0 or 1. Our all laptops, everything is now working on the classical bits. Okay, so there is in simple way, like how to put this entanglement is. Uh, how should I say, like how Einstein put it is like you have 2 gloves of right hand and left hand. Okay, and if I put that in 2 suitcases and I send it one to America and I kept one in India. So when the guy goes in USA, okay, and he opens his briefcase and check it is a right hand glove. So he ultimately knows that the other briefcase has left hand. So similar is the proof of what we can say, the concept of entanglement, that they are linked to each other and one state affects the other. That is how it is correlated. So, in what Einstein told is he called it spooky accelerated instance. Okay. So because it seemed to violate locality, like no signal traveling between particles. Okay. So even Einstein was partly wrong on this because, he thought entangle must be, due to some hidden kind of variables and all. But the Bell state that we are giving an example here, so it proved that it is not some hidden kind of thing. And it is what we can say, entanglement is completely real and all that. So even the geniuses are a little bit wrong on the side. So don't worry if you're not understanding quantum computing. So yeah, you're on the right track, because even a lot of quantum physics professors said no one can understanding, and if you are understanding it, you are doing something wrong. So this Bell state, the simple entangled state is called as Bell state. As you are seeing, like these two qubits are Ket0 and Ket1, and these two qubits are always the same, either both 0 or both 1. But which one happen when you measure it, it is random. Okay, so here also we tried to measure it at 1,000 shots, means 1,000 times, and we got that the Ket00 is like 504 and 111 is 496. Okay. So yeah, bro, scroll the screen. Yeah, sir. Yeah, let's go on the quantum gates. Okay, super dense. Okay. So the same, we'll apply the what we can say Bell state entanglement or such kind of thing for the super dense encoding. So what we will do, there is this allies and Bob. Let's say, in other words, senders and receivers. Okay. So what you need to do is you'll Alice and Bob will share an entangled build pair. Okay, they are correlated, interconnected, and Alice now wants to send her two classical bits, 0001, and two classical bits to Bob. Okay, now what will happen? Okay, so she applies this four operation that we'll explore further. That is identity X gate, Z, Pauli Z gate, and XZ gate to send her qubit in kind of using these gates, she encodes it and send it to Bob. Okay, and now Bob applies the decoding circuit, okay, C naught and H, and measures it. And Bob receives the alias 2-bit message, whatever the message. Okay, so don't worry, you'll see how this problem is. In the code, you will see how this problem is, and check it around. And the key idea is, so using one qubit and entangle, we can encode the two classical bits of information. Okay, so take it on to the new slide, yeah, sir. Yeah. So now let's come to the main part here, that is quantum gates. Okay. So as I was mentioning right now, Hadamard gate, C naught, Pauli X gates and all. So this is the very core concept. When you're solving all of this problem, you should have a good understanding of it. What are these? Okay. So these Pauli gates are the building blocks of the quantum circuits. Okay. So think of gates as an action you can perform on qubit, just like logic gates. So you all may be familiar with logic gates, on bits in classical programming, like NOT gates and all kind of thing. So similarly, in quantum computing, there are some certain gates. So these gates are like X gates, Pauli X, bit flip. So what you do is you flip the bit here, acts like a classical NOT gate. Okay, so it's swap like Ket0 to Ket1, like flipping a light. You can see it like a flipping a light on and off. So it's like that. Then there is Z gate. You call it as a Pauli Z gate. It does a phase flip. Okay, so leaves Ket0 unchanged, but flips the sign of Ket1. So let's say 0 is there, so it will leave it unchanged, but only Ket1 or the bit 1 will change its sign. Imagine it like as a sound waves. Okay, so you're flipping the wave upside down. Then if you are electronics, if you have used this oscilloscope, or if you're an electronics guy, you might get it more clear understanding of it. So basically, there is this wave, and you're just flipping it upside down like a sine wave or kind of thing. Okay. Then there is this Y gate, Pauli Y gate. Okay, so it does bit flip as well, bit and flip as well as phase flip. Okay, so what it does is it is a combination of X, what I can say, X, Pauli X and Pauli Z. Okay, but the twist here is because the twist of complex numbers, the rotation around Y X, as you can, the block sphere is happening. So what you can do is this swap 0 and 1 and add a phase change to it. Okay. And I think the fourth one is Hadamard gate. So this Hadamard gates, as I mentioned earlier, and you have seen a diagram of that circuit, it's introduce the superposition. Okay. Yeah, so change the slide. Yeah. So this, I think, okay, this is the C naught gate. Yeah. So C naught gate is like two qubit gate. Okay, one qubit is control, another is target. Okay, so if you control, let's say Ket0 is doing nothing, and it will do nothing. It will not affect any kind of what we can say another state of the qubit. Okay, and sorry, another what we can say the part of qubit. But if the control is Ket1, it will flip the target and apply X gate to it. So you can understand it in this way. that imagine a parent, okay, like the control one, control parameter of it, and the child, the second qubit, okay. If the parent is calm, okay, it is 0, the child stays the same. But if the parent is excited, let's say it's 1, okay, the first qubit is 1, the child flips the mood instantly, okay. So like if your parents are a little bit, in the anxious mood, will not ask for a chocolate or something kind of thing. So it is like when you're a kid and all. So it is something like, it's in nature. So here also mimicking some kind of thing here using C0 gate. Okay. Why it is important? Because C0 and HUDMART gate are enough to create an entanglement. So as we see some circuits earlier, and you will see that, using the codes as okay. Yeah. Change the slide. Yes, sir. Yeah. So this quantum circuit and measurement. So until you measure, a qubit is in a quantum state. So until you measure it, the coin is always flipping. It's in the air. Okay. Maybe superposition or entangled. Okay. Measurement forces it to choose an outcome, collapse. Either it will say yes, it is heads or tails. Okay. So if your qubit is in like this, example, what we can say, entangled state, measuring gives a random 0 or 1 with each of 50% of chance. Okay. Because when you flip the qubit, either it will be 0 or either it will be heads or it will be tails. Okay. So similarly, like you can with this coin, you can imagine it perfectly. Yeah. So nothing much more in that. And this quantum circuit, what is this quantum circuit? So this is a combination of these gates when you are applying with data. And when you use this, what we can say gates here, okay, all kind of gates that we discussed, Pauli X, all this gates. So we get this, what we can say, this quantum circuit. You measure it and you get output. Why this quantum circuit is important? Because what we can say, it allows us to encode this classical data. What data we have is not quantum. Okay, so we encode the data, we play with this data, whatever we have, and to perform this operations, quantum operation with the help of these gates. Okay, so yeah, sir. Take on the next slide. Yeah. So hybrid quantum classical algorithm. So what does hybrid means here? Okay. So this is like the mixture of quantum and classical. We can, with the what we can say, source and the complete framework, we can perform such kind of operations. So like the quantum part prepares states, measure outcomes, and classical parts update the parameters. So a beautiful example of this is variational quantum eigensolver. Okay. What we call it as a VQE. Okay. So VQ is like it is used to find the ground state energy, the lowest possible energy of molecules. Okay. So this is also relatable to your problem, one of the problems in hackathon. So how to solve it? Choose a parameterized circuit. We call these parameters, if you use Qiskit, we'll call this as ANSAT. ANSAT means this already existing parameterized circuit. You use that. Okay. This is like guessing the shape of a molecule of wave function. Like you start something, like you guess something at the very beginning, and then you update, run it on quantum device, measure the energy. If you see of energy is very high, we need to lower it. Then classical optimizer, what it does is it tweaks the parameter. Okay. And we get it repeats itself, like the iteration, how it repeats at a certain epoch, and we get the energy, the optimal energy, a lowest energy kind of thing, the parameters that you set. So here, all the measuring is done in the quantum device, but the classical optimizer is always tweaking the parameters like that. Okay. Yeah. Go ahead. Yes, sir. Change the slide. Yeah. Yeah. So, okay, it's basics of optimizations right now. So, okay, what is optimization? Optimization is one of the most important part. Okay. So optimization is what? It is process of finding the best solution from a set of possible solution. Okay. So let's say you want to, there are five cities that you want to travel. Okay. Let's say from Delhi, you want to travel at Kolkata, you need to travel at Andhra, you need to travel at Maharashtra, then Bangalore and all kind of things. So there are 5 different cities and there is certain cost involved. Of course, you're traveling and you need to deliver some parcels. Okay. So how effective you will, choose your cities, that this, what we can say, because there are n number of combinations. Okay. So how will you choose this, what we can say, this spike of in the proper combination, in proper order, that you'll get the most optimal solution, which is low cost and most efficient solution. So similarly, like for every other problem, there is this optimization. Okay. So generally in industry or generally in anywhere, it is involves like, maximize the profit or accuracy of the task. Okay. So if you solve some finance related problems, so it is like maximizing the profit. In the hackathon problem of, I think, the portfolio optimization, you need to optimize it for maximizing the profit of the, or maximizing the returns. Okay. And for some different type of problems, you need to maximize accuracy or something like that. But and another thing of these objectives are minimizing. Okay. So minimizing means lowering the cost, as I said, or error or kind of risk involving this. Okay. Let's say in portfolio optimization, you will minimize the risk and maximize the returns. So this is for what you will do, optimization. Okay. So there are certain things like in the right side of the screen, you are seeing this, there's some equations going on. So these are objective function. Okay. So, we are maximizing the returns, and there is this budget. Okay. So let's say you are putting your money in your portfolio. So the budget is that whatever money you are putting, that only we need to, algorithm need to suggest, right? So how an optimization problem is framed is like, there is an objective function where you define like what you want to do, what objectives you want to do, and which are subject to constraints. Okay. So this constraint are like, multiple constraint can be there, and with the help of this combination of objective function and constraint, optimization need to be done, and we need to find an optimal solution. Okay. Which is optimal solution means a good solution. Okay. So there are, for example, you are seeing this is an objective function. This mu is like sum of mu xi. So this is for maximizing the return, and the budget is this is budget constraint. So whatever the budget you are defining is the objective function, take it as 1. Okay, and you need to let's say you have 55,000 of budget, 55,000 rupees budget. So you need to what we can say, invest all of that money, not more than that, not less than that. Some play is allowed, but not more than that, not less than that, because it is not optimal. You're not having that money. So what is the use of investing and allocating such kind of money? And another constraint can be risk. So, you're saying that I don't want to go for higher risk, I want lower risk. Or you can, for aggressive, what we can say, investment or something like that, you can, if you want to take more risk, so you can formulate that can as. So optimization is whole things of maths, how you formulate it properly, how you think you as I said earlier, there are tools how you put them together properly, objective function, and how properly you're formulating it. It depends on your mathematical skill. If you have good interest in linear algebra, if you have good interest in maths, you should definitely take this problem statement. Yeah, sir. Go on the next slide, please. Yeah. So I think, yeah, this is QA and Cubo. Okay. So now what is this Cubo? Okay. So Cubo is quadratic unconstrained binary optimization. Okay. So it's a way of writing this optimization problem. You can say it is a way of representing. Okay. So the variables are binary. Each variable is 0 or 1. And this objective function is quadratic. Okay. Involves in the terms. This unconstrained means constraints are folded into the cost function instead of being written separately. So yeah, and okay, so basically, as you're seeing, this formulation is like minimize x transpose of qx. So this is the representation or formulation of this, and with the help of this formulation, you will try to formulate all these problem statements. Okay. So, and another aspect of QAOA, like VQE, this is also a hybrid algorithm. So, QA means quantum approximate optimization algorithm. So, it is a variational hybrid algorithm, quantum plus classical. So, how QAOA works? Okay, so basically, you set up a problem, you take the optimization problem, rewrite it as a energy function. Okay, you'll see the codes or something for it. Then you'll try to solve for lower energy, which is, as I said, better solution. Okay, so there is a thing involved called cost Hamiltonian. Okay, what is cost Hamiltonian? So it encodes the actual problem. It is designed so that the lowest energy state corresponds to the best answer. Okay, I don't know whether you guys are familiar with max cut or graph problems, but you can get a good or you can say these are used for you can use such kind of problems for that as well. So if you're solving a max cut problem on a graph, So this what we can say cost Hamiltonian is built on the edges of the graph. This is one of the example. So what is a mixing Hamiltonian? Okay, so this is a steering operation. Okay, this prevents the system from getting stuck. Okay, so imagine this optimization is like a landscape. Okay, there are hills and all. So where there is the lowest point of that landscape, you will get what we can say that is your solution. But sometimes what happens, it gets stuck due to it is not able to decide which step to take further. Okay, and there is then this that's why we are using mixing Hamiltonian. So usually chosen as something simple like flipping qubits or like that. And there is then alternating like this. We are applying this cost Hamiltonian, we are applying this mixing Hamiltonian, and repeat this sequence to get the lowest solution. Okay, and this what we can say this the classical optimizer like VQA adjusts the parameters like how long to apply each Hamiltonian, repeat until you get the conversation. So it is somewhat similar. Just here it involves cost and mixing Hamiltonian. Yeah. Go to the next slide, yeah, sir. Yeah. So what is quantum machine learning? Okay. So quantum machine learning is the intersection of, again, quantum and machine learning. I think a lot of people are now aware of machine learning. You're using the AI tools and all. So you know what is AI and what is machine learning. There are a lot of programs in undergraduates that are going on. So this uses quantum circuits to process the data. As we have explored earlier, what are different type of gates and all. So it uses the quantum circuits to process the data, extract these features into the Hilbert space. Hilbert space means this quantum space. Okay, so this is nothing like classical. This is a different kind of space where all the features are mapped and the expressivity of it is very high. Okay. So this leverage the quantum properties, as I said, in the circuits like superposition, entanglement to encode the and manipulate the data. And why? Okay, the question here is like we have already the AI is too good. Okay, you are seeing the GPTs, you are seeing this different kind of machine learning models over internet. So why QML? Why do we need quantum machine learning? Because still machine learning has its limitation. Okay, so this high dimensional data like genomics, finance, which is very unpredictable, certain kind of image analysis and all, these are very high dimensional data. Okay, and these are like what we can say very complex to solve the problem. Okay, that's get me to the point that people, I don't want to give any wrong idea to you guys that quantum is something very phenomenal. Okay, so I want to clear you this that quantum is of course very great, like what we can say very different. It is what we can say, instead of you saying it is always overpowering classical or something like that, it is different than classical machine learning or classical concepts. But it is not necessary that always quantum will win in the situation, but it is definite, or it is very potential that quantum machine learning, what we can say, will be able to solve high dimensional or complex problem. Generally, why we are moving towards quantum computing is because it's not because it is easily able to beat the classical computer. We are all these super servers and kind of thing. Is because we are trying to solve complex, a different set of problems which are very hard to solve for what we can say classical computers. Okay, with even with huge servers and all, you are not able to solve such kind of problem. So that's where quantum machine learning comes in the picture. Okay, so okay, so I think I should have given this example earlier, but I think it's better like giving an example how about this. So Bhulbulaya, then what we can say an example of maze game. Okay, we call it in Hindi is Bhulbulaya. So we start at one point and you need to go out of the maze at one point. Okay, so you will do it easily. Okay, any classical computer do it easily when there is like only few traps are involved, few blockages are involved. But imagine there are like hundreds and thousands of ways to solve it. So now how this classical will solve? Classical will solve it very sequentially. Okay. So sequentially means like it will go one by one. Okay. It will travel at the first beginning. It will stop. Okay. Yeah, I hit the dead end. I need to go back. I need to choose another way. It will go deeper. Again, it will stop. Oh, I hit the dead end. I need to go back in the another way. So there are like n factorial number of possible ways to solve that kind of thing. So what quantum does is it allows parallelism, this superposition. Like I said, coin is flipping. So this what we can say, this superposition will allow to go in each and every path. Okay, at the same time, and entangle will, which mean what is happening to the this all the paths. Let's say 1,000 ways we are exploring to solve that maze, Bulbulaya, and first one hits the dead end. So all other will know this is not the good path. Other one hits the dead end. All other will know like it is not the good path. Let's say the 500 path shows the solution. So we instantly get that okay, this is the solution. This is how you can say that how this superposition entanglement works in the combination and solves the complex problems very efficiently. Okay, so let's coming back to quantum machine learning. So okay, we'll see now how to what I can say, how to encode this data. What are the essential concepts for quantum machine learning? You'll solve this fraud project in your hackathon and other projects also with the help of this quantum machine learning. And yeah, go to slide 17, yeah, sir. Other side, yeah. Yeah. So this is quantum data encoding. Yeah. So what is like what we can say? What is this quantum data encoding? So the data right now we have is not quantum. So this is classical data that we are dealing with. Okay. So we need to, as I said, the Hilbert space. That word I use. It is a dimension where you represent the classical data into the quantum state, that the language which quantum computers understand. Okay. So when you are doing this, what we say, quantum data encoding, like basically what you're doing, you're mapping your data into the quantum states. Okay, like this superposition, entanglement, and like this, as I said, Ket1, Ket2, and all kind of thing, using this superposition and other things, gates and all. Okay, so there are three major type of encoding strategies, with the help of which you can encode this data. So this is basis encoding. Okay, basis encoding means simply putting your data, mapping to one-on-one and putting into the quantum. Okay, so it is very simple. If your data is 0, you'll map it at Ket 0. If your data is 1, you'll map it at Ket 1. It is very simple and intuitive. But the problem is it requires a lot of qubits. Okay, so each classical bit corresponds to 1 qubit, and it is not a if you're solving a very big problem. So it is not a good way to choose basis encoding. So as you're seeing, so for small data sets it's okay, but let's go to this coding example. So this is the data that we have. Let's say 101, and you're creating a quantum circuit. Okay, and if the bit is 1, means if it's 0, you don't need to apply such any. You can directly convert it. But if the bit is 1, you need to apply the X rotation gates, and you need to what I can say, use these operations to get into the quantum what I can say, quantum states. Okay, so here you are seeing the first one was these are three data, like Q0, Q1, and Q2. Okay, so Q0, you're seeing an X image in the output. So means when the like the data was 1 or bit was 1, you are applying this gate. Okay, the second one was 0, so no operations, and the Q2, that is the third data point or third qubit, where again it is 1, so you are applying some operations to convert into the classical state. Okay, so this is very simple example how we can do it. And as you're seeing, the libraries that are imported here is Qiskit. So Qiskit is introduced by IBM, and they are maintaining this repo on Git and all. And you'll use this to solve many problems in this hackathon. So in the next phase of this bootcamp, we'll see how this, what we can say, how we are solving this problems using Qiskit, and what are these. Okay, so even okay, let's go on the next slide. Yes, that is of amplitude, I think.
I request Mulani sir, please disable invitation to participants, sir. You can see that option at more options, sir. You please go for more options, and there you see disable for annotation to others.
Yes, sir. Done.
So you can erase earlier annotation, sir, which we are seeing in the screen, or you can simply reshare the screen. First of all, you stop the screen. Some symbols also you need to erase that. So request all the participants don't do annotation to the screen.
Okay.
Yeah, please
Okay.
continue.
Yeah. So let's start this. What I can say, amplitude and encoding. Okay. What are this amplitude encoding? So it is like it represents the again, we are doing this to encode the classical data into the quantum states. And the way we are doing is like the 2 raised to n qubits are been amplitudes are been what I can say converted into the Hilbert space. So I'll instead of going into more theory, I'll just explain with the code. There is a lot of noise actually. Yeah, thanks. So let's take this example that again you are importing quantum circuits from Qiskit. Okay, then you're using this Qiskit's. You are initializing the states. You are seeing that there are two data points again that are 0.6 and 0.8. What we are doing, we are normalizing this data. We are initializing it, the gate, and we are using. You are seeing the QC is equal to quantum circuit 1. Okay, so why 1 here? So as you're seeing at the left side of the screen, that is it 2 raised to n. So these two amplitudes can be represented as 1. Okay, so why 1? So for example, 2 raised to 1 is equal to 2. So let's say if there was here four data points, okay, 0 0.6, 0 0.8, 0 0.10, and 0.12. So how would we represent it? We would have represented by 2 raised to 2, that is quantum circuit 2. So we are doing it. So it is one of the most efficient methods to encode the what we can say what this classical data into quantum. Why? Because with just 10 qubits, you are able to encode 1024 samples. Okay, because 2 raised to 10 is equal to 24, and because of this, you can perform certain operation in your laptop as well. Okay, so it is one of the most efficient way, and I recommend when you are solving such hackathon tasks, it is one of the good method that you can do it because it can handle this high dimensional data. If you have a lot of features and you need to map these features to the qubits, you need to use such kind of amplitude encoding. Yeah, next you can take it. You in the output you are seeing that all are in the psi and kit psi, and you can see 0.6, 0.8 in the 1 qubit. Yeah. So now this rotation encoding. Okay. So we are using the rotation gates here, Rx, Ry, Rz. So what it does is it's in the block sphere that you saw a sphere earlier. It rotates the what it is around x-axis, y-axis, and z-axis. This allows us to tune, like play with this quantum features and relocate it to the give us the best optimal results. Okay. So each data value we can use this, as I said, Rx, Ry, Z, and it is one of the easiest method to implement and scale linearly with the number of features and qubits. So in this example you are seeing, so this is like you are again importing the quantum circuit, and the data point you are defining is 0.5, and with the qubit with the help of 1 qubit. You are multiplying it with 0.5 into the first qubit, and you'll getting the pi by 2. That is 180 by 2, 90 degree of the rotation along the y-axis. You are using the Ry gate, and this is you are seeing this the visualization of here. Okay. So yeah, take it further. Yes, sir. New slide. Yeah. Yeah. So I think the new slide is on quantum models. Yeah. So what are these quantum models? Okay, what are this? This is one of the most important thing if you want to solve these machine learning problems in hackathons as well. So these quantum models are variational quantum circuits. Okay, VQCs. Okay, these are parameterized quantum circuits with tunable gate angles. Okay, so think it like VQC like a quantum version of a neural network. In neural network, what you are doing? You adjust the weights on edges to make it better prediction. So similarly in VQC, we adjust the gate angles. Okay, like this Rx theta, Ry theta, and to shape the quantum states. Okay, you are doing the data encoding, as we mentioned earlier, you are using these parameterized gates are like layers with tunable weights. Yeah, how you tune it neural network measurement is like reading the network's prediction. You collapse this qubit and get the numbers. And optimizer is like the coach. You can say it as a it looks like it's look at the prediction versus the target and updates the angle. It tunes always. This is how you train the neural network. Similarly, you do here as well. And okay, I think VQC is okay. So let's understand this example. Okay, so what is this example? We set up a 2-qubit quantum device with the help of Penilyn. Yeah, Penilyn is also one of the state vector simulator offered by Xanadu. They have created Xanadu company, and this Penilyn is also used for like quantum machine learning tasks, quantum tasks, which is a counterpart of, or we can say another option we have after Qiskit. And with the help of this framework, we are solving this VQC problem. So we set up a 2-qubit quantum device here. As you can see, n qubits is equal to 2. And we are choosing the quantum device that is default dot qubit, which means you are using your CPU. There are options available like the default dot qubit, lightning dot qubit, where it uses your GPU and all. And you define this qubits of yours, and I'll walk. Then what you can do is in the function VQC params, you're seeing this params x. The input data is we are giving it as x is equal to 0.512 in the downset. You're seeing this data, right? Is first encoded into the qubit rotations using angle embedding. Okay, this QML, this is a template, QML dot angle embedding. And this means the classical numbers are turned into the quantum states. Then parameterize and sets. And set means they have already. You just need to load it. Okay, that you just need to define it. That is strongly entangling layer. That is applied here. This layer contains tunable rotation angles and entangling gates controlled by these params. Okay. So this idea is that during training, this rotation angles and entangle gates controlled by these params will be optimized to fit a task like classification, regression, or energy minimization, whatever you are solving this VQC. Okay. So in short, we can say and then you measure this again. You measure it, and we can see this. We got the this 0.38 as our answers. With the help of we measure it with using Pauli Z, and we got these answers. So in short, this code build this hybrid quantum classical model. Okay, that based on this, and again, you can do this in your classical computer. You don't need a quantum hardware. This is kind of a simulator that you are using. Okay, next, go for the next slide. Yes. Yeah. So I think this is kernels and neural networks. So yeah. So what are these kernels? So similarly as classical learner, we are trying to find the what we can say similarity of 2 points. Okay. So a quantum kernel does the same thing. Okay. But instead of mapping data into some hand-designed higher dimension, it maps into the Hilbert space of a quantum system. Okay, which is huge, exponentially large. We can say with the number of qubits as you increase the number of qubits. And the quantum computer take 2 data points, encode it as quantum state, and then measure. Like the same process is followed everywhere. Okay. So and how they do it? By taking the inner product between the 2 states. Okay. In the kernel thing, the similarity score becomes the kernel. What they do? They took the inner product between the 2 states. Okay. The hope is that this giant quantum space patterns that are tangled in classical space become nicely separable. Okay, because with this huge space, you are able to in this kernel, you are able to see this what we can say analyze each part of thing. So using quantum state as here what you are doing, just using quantum state as fancy feature space for machine learning. You'll find this Qiskit's quantum ecosystem. You'll find some examples over there. And even Yasser will do some, what we can say, show you some codes. Then I think there is this quantum neural network. Similarly as classical neural networks, we are using some hybrid workflows. And the quantum computer handles the quantum circuits. Classical computer handles the optimization. And first you take this classical data, like the number of images, and encode it into the qubits using methods such as rotation, amplitude, or basis encoding, as we said, and use the variational quantum circuit, as I explained earlier, and which has tunable gates angle like that. And you perform a neural network operation. This is now active area of research of interest. So because there is trading time that we are seeing is quite high, we need to slow it down. And there are quite a challenges today, like noises and errors. In the current quantum devices, as I said, we are in the NISQ area. These are very noisy. There are decoherence. There is different errors that are happening in qubits. So these qubits lose information very quickly, and we don't get the accurate results. Okay, there is this barren plateau. As I said, imagine a landscape. Okay, sometimes what happens, the gradients vanish in the big circuits. So this training gets sucks. You'll see that kernel is busy. You're running the simulation, but you're not getting anything. Okay, and this data is encoded using bottleneck. Okay, so like for what I can say is finding efficient way to put your data into quantum state is still research, because this converting this data into this Hilbert space is still a challenging part. It's not as easy, because you saw some three things, but it will not always use for every task. Okay. So there are active research going on. It is still part of research. And scalability, because these are very computationally costly. Scalability and the current NISQ limitations, we are not able to find some scalable problem. So also hybrid quantum machine learning means classical and quantum machine learning mixture are arising into the charge. And benchmark, it's still like as I said, quantum is used for solving complex problem, but definitely complex problem requires a huge cost. And on the simple problems, like it is better that classical is doing very fast and efficient work. So it is still hard to prove these benchmarks that definitely quantum machine learning beats quantum neural network beats the classical one, but in lot of like complex cases. But still like finding the right applications, or finding instead of saying right application, finding the complex application, creating the complete framework for it, solving it, and then showing the results still take some times, and still it is active area of research, because you always need to tune it. You need to find the way. Okay, you need to find the solutions for it. Okay, so yeah, go ahead. Yes, sir. Next slide. Yeah. So as I said, training are a lot of challenges. Training is one of the big challenges here. So we need to training and challenges today, like Baron Plateaus, this data encoding, scalability, benchmarking. So, but definitely for higher QML, what we can say, higher dimensional QML tasks, practical training is limited today due to NSK, but definitely when it is scalable and all, we'll able to solve this kind of problem. Yeah. So I think you now Rakesh will go and take some examples, and you'll able to relate what is happening and what is going on. Yeah. So you'll see the codes, and he will explain you like all the theoretical concepts that we have learned, how they are performing in the actual course. Go on, Rakesh.
Yes. Hello, everyone. So Rishikesh now explained the concepts, like he covered most of the things from like basics to coming to quantum machine learning and challenges in machine learning. So now what we'll do is we'll go through some sample codes, what he explained, and me and Yasser will go through some codes. And at the end of the session, we all together we solve a problem, so that you'll get an idea like how to approach a problem while you are like solving this problem or any problem in hackathon. So I'll share my screen. Yeah. Let me know if you're able to see my screen.
Yeah.
Yeah.
Okay. Yes. Okay. So Rishikesh started with basic concepts. So we'll go one by one how these concepts. So like why these notebooks are created is like as Sar said that like many are beginners in this quantum field. So we want that beginners to feel that like feel that they are doing some quantum as well. So this gives some basic things for them to start with this hackathon or start their quantum journey. So you can see that we'll start with the superposition example. Now, so what is superposition? So a state like at a time it is having in multiple states, but when you measure it, it collapses to one. So how that is achieved actually? So that can be achieved using a Hadamard gate. So when you apply a Hadamard gate here, you can see that after constructing this circuit with Hadamard gate and running this circuit, you can see the final output that. So most of the time, so we have ran it for 1,000 times, but you can see that it is like half of the time falling into 1 and half of the time falling into 0. So you can see that it is in superposition of 0 and 1. And the next concept that is entanglement. So this entanglement, as Rishi explained, so they are like strongly correlated. So one one qubit affects the other. So you can see that it can be achieved using Hadamard gate and a CNOT gate, and we construct the circuit and we measure it, and you can see that the measurement outcome. So if it is 1, so the other qubit will always be 1, and if it is 0, the other qubit will always be 0. So these two qubits are strongly entangled. So you can see that one output affects the other. And yeah, so also one interesting concept explained, that is superdense coding. So what is this superdense coding is, so unlike teleportation where you transmit the qubit information, but here what we will do is we transmit the classical information from Alice to Bob. So what they'll do is, so they share this entangled pair, Bell state, and they create that Bell state and they share that Bell state. And Alice wants to send some information, that is the bits to Bob. Now what he will do is, if he wants to send some particular bits like 0, 0, 0, 1 or 1, 0, then what he will do is, according to that, what he wanted to send, he'll apply a gate to it. And this will change the state, and after like whatever he wants to apply, what Bob will do is, Bob will apply C0 gate and Hadamard gate to that circuit, and he gets the information what Alice wants to share with him, the classical bits what Alice wants to share with Bob. So you can see, and so if Alice wants to send 0, 0, you can see 0, 0 as the output from Bob when Bob measures, and 0, 1 and 0, 1 and 1, 0 and 1, 0. So 1, 1 and 1, 1. So this is how superdense coding is, like generally like a basic implementation of superdense coding. Now coming to gates, Rishi has explained multiple gates and like rotational gates and all. So we'll see some basic NOT gate and Y gate and Z gate here. So you can see that first, so this is the first, I'll introduce what is this representation. So this is a block sphere representation of a qubit. So here the qubit is in state 1, but if the arrow is pointed towards like upwards, then it is in state 0. Now this block sphere representation is representing the state 1, like ket 1. Now how this is achieved is, this is like by applying the NOT gate, and similarly this Y gate and Z gate are applied, and you can see the.
Sir, can this code can be zoomed, sir? Zoom out? Can it be possible?
Zooming.
Codes.
Just a second.
Okay, if it is not possible, no issue.
I'm just trying, sir.
Yeah.
Yeah. And you can see the Y gate application as well. So when you apply that Y gate to the qubit 0, it will land the ket 1, and you can see the Z gate as well. So you can see now, yeah. So these are all the rotation gates. Now what I want to cover here is, so this hybrid quantum algorithm VQE, like this algorithm is like considered the most important algorithm like quantum, because this is used for many applications. Like the one application that we are applying is estimating the ground state energy of a molecule. So you can see, so what as Rishi explained, so what a VQE does is it calculates the minimum eigenvalue of a particular Hamiltonian. So we'll construct a Hamiltonian and we'll create an ansatz, and what an optimizer will do is it optimizes the parameters in the ansatz, and at the end it will land into a more optimized parameters where we'll get the minimum eigenvalue of that Hamiltonian. And you can see, so we constructed a Hamiltonian and we did and estimated the energy, the ground state energy is something like this. And yeah, so you can see the data encoding as well as, so this is the basis encoding where this will be straightforward. If you want to just reflect your classical data one into your quantum data, then what you will do is you'll just apply the NOT gate. So it will be converted to 1. And if your classical data is 0, then you don't do any operation on the circuit. So this is how some basic encoding is done, and yeah, amplitude encoding and all of this. So these are some basic examples that I'm discussing. Now Yasser will go through some one more example in machine learning, and at the end we'll see a practical implementation of one problem, which will give you an idea like how to approach. So Yasser, you can continue. So after your thing, we'll end the session with that problem.
Yes, thank you, Rakesh. Just a minute, I'll share my screen. Is my screen visible?
Yes.
Okay, so here we are going to create a quantum kernel and run an SVC algorithm over it. So first we import few libraries from Qiskit, that is Qiskit circuit library. From Qiskit machine learning, we import fidelity quantum kernel. We use the SVC from the sklearn, and for this particular problem, we are using the ad hoc data created. We are creating a simple data set with 30 samples, of which 20 will be used for training and 10 for testing. So we create with 2 data points, that is 2 features, we create this data set. As I said, 20 train samples, 10 test samples, and we have a gap of 0.3. That means how the points will be in the space. So this fidelity quantum kernel, in this we like we can say that it tries to check overlap, what features are overlapped in it. So we use quantum kernel for that, and this is how the data set is plotted in the space. We use the ZZ feature map to convert from classical state to quantum state, and then followed by we take it into quantum kernel. We convert the further we use this one hot encoding to convert the labels of the data set from one hot to integers, and we run the SVM algorithm over it. So if you can see, we got an 100% accuracy over this particular problem, and we also plotted the decision boundary for this particular problem. So with the 100% accuracy, we can get this kind of decision boundary towards it. And this particular we can use like various algorithms instead of SVC. I've used SVC because it's lightweight, and my PC doesn't support that kind of computations, higher computations. So this is what quantum kernel does. Yeah, Rakesh, you can take over.
Yes.
So these are the, what we can say, the content that we'll share it to APSI, and APSI can forward it to all the PPT, the notebooks, and the examples. So you can refer this while preparing for the solutions for hackathon. Yeah. So yeah, Rakesh, go on for your the test notebook. I think sir, you shared this test notebook with everyone, right? Dr.
Yeah,
Kumar.
sure. Yeah, sure. Sure, I will share.
Yeah. So guys, you can just install these libraries. There are some commented out, and you can see. Rakesh will guide you through it.
Yes. So so the thing is like from this particular notebook, what we want is we just want to introduce some optimization problem, not like we are not specifically saying, okay, you solve this particular problem, portfolio optimization, only using simulated annealing, only using DWave. What we wanted to tell you is a problem can be solved this way, but there are multiple ways as well which you can explore. For every step, I'll give you what are the different ways that this problem can be approached, and this applies to different problems as well. Okay, we'll jump into it. Now see. Okay, now we are solving here is a portfolio optimization problem. Now what we are doing here is we are using DWave and DWave library and simulated annealing of it. We can actually use the hardware of DWave. And one person, like one participant asked in this session that like other than IBM, what are the other platforms one can use? So this DWave and of course Confluence. Sujay joined the meeting, right? So of course Confluence will also be used. So these are some kind of hardwares which can be used as well, apart from IBM. Now jumping into it. Okay, so now we are using this. So the required things for this problem is for this DWave is we need DWave Ocean SD, and we needed DWave Neil, and we'll import the necessary things. Now, before jumping into the problem, what we generally like before solving any problem, what we generally do is like, what is the data it needs, right? So what is the data it needs? So for this problem, there are only there is minimum data needed, like not huge data, but for this demo, minimum data needed, that is the mean returns and the covariance matrix. So this will be used for this problem, and other parameters such as the number of assets and the risk aversion factor and penalty. Now coming to the important thing, that is the problem formulation. So now we have this goal of solving a portfolio optimization. Now how do we actually formulate the problem? So what is our objective and what is the constraint, right? So even this applies to if there is any other optimization problem in the given hackathon problems, the same thing applies. Like you need to formulate the objective function, you need to formulate the constraint, and you need to put it into an equation where after putting into that equation, you will need to convert that equation into a cubo form. So first, here the formulation that we are taking is, I want to maximize returns and I want to minimize the risk. And the constraint that I have is I don't want to select, I don't want to go out of the selection parameter. For example, if I want to select only 2 assets, if I'm creating a portfolio, I want to select only 2 assets, then the constraint here is 2 assets. So now you can see that it is beautifully formulated into this single equation. So this mu is the mean returns of the stocks in the portfolio, and this sigma is the covariance between that stocks, and this lambda is the risk aversion parameter, and this k is the selection limit. So as I said, we want 2 stocks to be selected, so this k is the selection limit. And the thing here is this, you are seeing the variables x, right? So this x is called the decision variables that we are using. So if x equals to 1, then it is that we are selecting that asset for our portfolio. If x equals to 0, then we are not selecting that asset. So I'll move forward, and I hope you understood the formulation. So this applies, like this formulation you need to kind of follow, like not exactly this formulation, but this approach of creating an objective and adding constraint to it, and forming an equation applies to any optimization problem that you solve. And now going to the next thing. So here you are seeing a term BQM. So many of the people mostly don't know what is BQM is. But before going to BQM, what I'll introduce is like Cubo, which is like already covered in this session, where Cubo is the model, which will construct for any optimization problem. So any optimization problem, this equation will be converted into a Cubo. So you can think a Cubo as a matrix. So we'll construct that matrix, and this matrix will be used for solving the problem. So this matrix can be given for IBM or this matrix can be given for D wave and confluence. So this cubo formulation is important here. Now, here I went, solving this problem using a BQM, model, which is provided by D-Wave. But the other approach that you can use here is you can form a direct cubo, a matrix for this problem, and you can give that cubo to any platform that you want. Now here I used BQM, right? Now for this BQM, I need to add the linear coefficient and the quadratic coefficient. So when you come to this equation, when you expand this equation, you'll generally see two types of constants. One is the linear constants, like the linear coefficients, and the quadratic coefficients. Now we need to encode that linear and quadratic coefficients into a matrix. So that is called actually a cubo, right? Now that encoding is actually done here using that BQM method from D-Wave. But as I said, you can also form that using like you can form like you can use any method which you can form. The end goal should be a cube. Now I have given the linear coefficient, and I have given the quadratic coefficient, and I have also given the offset. Now I have constructed a BQM. Now I have a BQM. Like I said, it will be a matrix, right? So you can see that. So this is like in a JSON or dictionary form. But if you can see that the variable 1 and 0, the interaction between like the coefficient of variable 1 and 0 is some 10.0006. So and the coefficient of variable 2 and variable 0 is like the decision variable 2 and decision variable 0 is 10.012. So this is how like if you put into a matrix, it will become a matrix actually. So now I formed the cubo or the BQM, whatever, for this optimization problem. Then now the next thing is I want to choose a platform to solve this problem. So here I used D-Wave. Now you can use Confluence as well. Now you can actually use IBM as well for solving this problem. You can use VQE and QAOA also. They can solve this optimization problem as well. So here I used a simulated annealing sampler. We can actually use the hardware of D-Wave, but we don't have access to it because it ended the access to general audience. So I used a simulated annealing sampler, which mimics the D-Wave system, and I have given the BQM to it, and it returns. So it returns the lowest energy sample to me, and you can see. So I have decoded the result from the D-Wave, and I've shown here. So what are the assets that are being chosen? And so out of 5 assets, right? So what is the data we have given? Yeah, 5 assets. So it has selected 2 assets to for you, saying that okay, consider these stocks for your betterment of portfolio. So it reduces your risk, it maximizes your return. So it is saying that, and you can see the energy. So it gives you the energy, minimum energy. So this for this particular sample, the energy is minus 0.45. Yeah. Now this thing is for like standard thing that I created, which is a basic thing for this problem. But the other thing that we wanted people or the students to do is we want them to experiment actually. And this experimentation is not only restricted to this problem. For example, Rushikesh has explained what are the gates, what are the like other concepts like entanglement, superposition gates, and rotation gates, VQE and QAOA, everything. Now, what you have to do is you introduce concepts. Now, what you actually experiment with this. You can go and implement. So what is this VQA? So I'll implement this VQE. So this VQE or this QAOA, whatever you do in this experimentation phase will help you in your hackathon phase for any problem that you'll choose. So for this problem, we are given that kind of experimentation to you as well. So here, these are some basic experimentation that we have given. That is, you can change the mu values and you can change the covariance values. But some advanced experimentation that you can do is like which you will do if you choose this problem is you'll change the objective function into a better version, and you'll change the constraints into a better version. You'll add more constraints to it. So that we will do in this, that you will do in this experimentation phase. But for some basic experimentation, what we created is you can change some mu, and you can change the number of assets, and you can change the number of assets that you want to select, and risk aversion factor, and you can play around. So this notebook will give you for reference for people who want some basic introduction. And I hope like you got the idea like what I want to convey through this notebook, what I also meant for other problems as well, what you choose. And I hope like I got to that point. And with this, I want to thank you for giving this opportunity.
I think all the participants have this particular test notebook, and the other one also will share it across. Perhaps she can will share it to Dr. Kumar, and Dr. Kumar can share all the participants along. Yeah.
Yes, sir, we'll share it.
Yeah. The session is done from our side.
Can we ask some question and answer session, sir?
Yeah, I think so. For 10 minutes, 5 to 10 minutes, we can.
Yeah, now the floor is open for question and answer session. Please, one by one, I request the participants and the mentors also, please monitor your students. You can ask the questions now.
Please make hand raise, and then we'll give unmute option.
Any participants, please raise hand. This is the right time to utilize the opportunity because there are 3 experts who are actually working on this quantum technologies.
Yes, please unmute and ask questions. One by one only.
Hello, sir. Hello, sir.
Hello. Yeah.
Sir, namaste, sir. I am from RVS Lalita from Aditya University.
Yeah.
Hello, sir.
Yes.
Sir, I have one question. Actually, we are implementing quantum key distribution and all on Qiskit. And now you have hardware also for implementing the same. So whatever the experiments we are implementing on the hardware, can we implement the same using Qiskit, or what is the interrelation between these two?
So to perform operations, you definitely require, to perform any operations, you'll definitely require these frameworks like Qiskits and all. And then you can run this on hardware.
Sir,
I think
my doubt
sorry,
is actually this, sir. Suppose I am implementing a program on Qiskit. So when I implement on hardware, I have to change the code and I have to run the same task.
No. You just, that's why these simulators are there. So that mimics the behavior of actual quantum hardware. You just need, like when you're using hardware, you just need to follow some guidelines of there. That is that API keys and job submissions and retrieving jobs.
That is I have done, sir. API key, CRN, I have all taken that. That I have done. What I am, my doubt is There are some kits are there, no sir? Hardware kits are available from startup companies.
So I'm
So
actually not
using those kits also we can do quantum key
QRNG.
distributions, no sir?
Oh, okay, yeah, QKD. Yeah, I think Rakesh can
Yes
answer
sir,
it
quantum.
better. Yeah, yeah. Rakesh?
Yes. Yeah. So the problem statement is QKD simulator, right? So as you said, you are also having some hardware to do that. That can be also done, but how you present it in a hackathon, because we kind of
Not for
expect
hackathons, sir.
this
This
to
is
be
my doubt, sir. This is
uh-huh,
my doubt only, sir, not for hackathons.
uh-huh.
The programming
Okay.
on the hardware kits and the programming on the diskette both are different, no sir?
No. That's what I'm saying. That what you can say, you simulate what will happen in hardware. You simulate with these frameworks, and then you just use these keys just to submit the job on hardware. You don't change any main core aspect or part of code, or you don't change any such kind of thing. You can you can add noises. So right now we are in NSK, as I mentioned. So you can use these kits to add some random noises to see how this will perform on actual hardware. So there is, as you're saying, there is no such changing of codes, or what we can say, using different sides of things. But you definitely, if that particular hardware is not supporting few things, then you need to define few things in a different way. But the core aspect, and that will not change. Yeah.
Whatever they provide, we should do those experiments only, no sir?
Yes.
Okay, thank you, sir. Thank you very much. Thanks for
Hello,
giving
sir.
clarity.
Hello, sir.
Sir,
Good evening.
I'm having a hard time understanding phase change while representing qubits in the form of block spheres. Sir. Could you please brief on that?
Yeah, I think visually we can. So basically, yeah, do you know a sine, a musical amplitude or sine wave kind of thing? So phase changes means you're changing its phase. What we can say, you're flipping it. You're flipping the phase of it. Okay. So in that way. So I think it's when you will visualize it, when you will do some experiments, it will be very, what you can say, yeah, it will be easy for you. So along with that, I think it's better to give participants some links of playlist of on YouTube and some Coursera. I don't know, like, I think a lot of institutes now allow to get some Coursera courses for free, because what we have given here is the content which are limited to hackathon. Okay. So when what you can say, when you're learning this with the proper order and proper flow, you'll get a deeper idea. Yeah. So I think we'll do that for you. So we'll send few links, few materials to Apshi, and Apshi can distribute it to everyone. Yeah.
Yes.
Good evening, sir.
Yeah.
Hello.
Yes.
Sir, actually, I chosen first program.
I think that is
Hello.
QRNG. Yeah,
Am I
that is
audible, sir?
QRNG. Yes.
Yes, sir, QRNG. After creating the code, we need to create an application for a friendly user, for end users.
I don't know, like Apshi has that idea for that, like what is the end goal you need to, or what is the objectives you need to do for it. But I just like we just perform that, you need to use this HUD gate and all kind of things to, I just give you the basic what to do for that, and objectives and the detailed problem statement Apshi can decide.
Hello.
Sorry, yeah, your voice is little low.
Hello.
Yeah.
The first problems, is it possible to provide FPGA-based prototyping for me?
I'm sorry, your voice is quite cutted. I'm not able to check. Rakesh or Yasser, if you heard that, please, like.
No.
First two problems, can we provide FPGA-based solution for the hardware problem?
Still, Okay, can you type it, sir? So,
Good afternoon, sir.
hello.
Yeah. Am I audible,
Yeah,
sir?
I think, yeah, you're audible.
So for the first two problems, can we provide FPGA-based solution prototyping for this?
Yeah, I think with the base course that we have demonstrated, we'll definitely provide that. That will be there for the reference. Yeah. So, but a complete prototype we cannot provide for that. So, the students need to explore for that.
Oh, okay, sir. Thank you.
Mhm.
Hello, sir.
Yeah.
So I selected third question.
Which one?
So third question, sir. Qubit visualization.
Visualization of block spheres. That one.
Yes, yes, sir. So,
Ha,
sir,
ha, ha, ha.
if I want to deploy it to on a server, sir, after completing the whole application.
Mhm. Yeah, you can. I think like you're solving it, you have your own solution. Like it's the approach of like when you get the detailed problem statement from AppSci and all, we'll try to solve that problem according to you. You'll have your own codes and you can deploy it. On render you can deploy it. You can deploy it on different services. So yeah, I think there should be no issues because it's your own thing. But you can consult with AppSci once.
Thank you, sir.
Yeah, I think someone has raised their hand. Karunya. Yeah.
So for the problem statement number 5, do you know how many elements are we supposed to include? Like it's just very vague, like only small molecules. Is there any specific number of molecules?
Yeah. Is it VQE?
Yes, sir. Yes,
Yeah. So again, the detailed problem statement will be given by AppSci, and you can then. But they wanted it to the small molecules. So definitely, as one of the examples you'll get after this call in the notebooks, you can refer to that. But again, like the elements and other things will be, you can decide it once you have the detail. Like you'll get that maybe problem statements, or you can whatever the benchmark will set for internal hackathon and all. So yeah, it is like varying on what molecules you are trying to simulate or what data you're trying to simulate and all.
Thank you, sir.
Mhm.
Hello, sir.
Yes.
Sir, can you suggest me the best tutorials for learning circuits, sir? Quantum circuits.
Yeah, I think the basics you can cover with this, Prabha Mandayam's course of IIT Madras on NPTEL. In that course you'll get a lot of things. But if that looks very hard for you, there is this course on Coursera, fundamentals of quantum and all. So I think just give me a second. I'll just look that and I'll share in this call itself. Give me a second.
Okay.
I shared it to some student earlier. Just a sec. Till the time, Rakesh, you can answer a few of the questions.
Yeah.
If anybody has question on that, other questions like PO, fraud or like that as well. Welcome. So I think there are no questions. I'll just share this with the team. Are there any more questions?
Sir, is there any meeting tomorrow?
No, madam, this is the end of Bootcamp. Sir, I would like to introduce very important person now to all the audience. My dear students, the man who is behind this AMARAVATHI Quantum Valley from IBM 156 qubit mission. When I requested, he is busy with our Honorable CM there in Delhi, but still he made it possible for you all to inspire you all. Now I request Dr. L. Subramanian Garu, Venkat Subramanian Garu, ఒకసారి నా క్వాంటమ్ బుక్ ఉంది పట్టరా నా టేబుల్ సార్ ఆర్ యు దేర్ సార్ you can unmute your video.
Yes sir, I am here. Thank you so
very
much.
Sir. Thank you.
Yes,
Within short time you have connected. That shows your passion and commitment to this quantum nation. Actually, this is the man who is inspiring, who is innovator, who is actually working day and night, and he is known throughout the world. Wherever you go, whether it is US, France, Australia, London, wherever you go, his name is there with golden letters. Sir, we have conducted 2-day boot camp with experts who are actually working on this. Now there are 3 experts are there, sir, Rishikesh and Rakesh, and Yasser is there. And the previous session was dealt by Suzai. Yesterday also there is 2 experts are there. So, sir, there are almost around 20,000 students across India, not only from AP is representing more students, and there are students from Maharashtra, there are students from Punjab, there are students from Rajasthan, Tamil Nadu, Karnataka, Telangana, like this. So it's a very wonderful, inspiring moment for all the students. Here is a man who is actually working. He has, to his credit, more than 35 patents are there. And most of these patents are on quantum computing, quantum technology, and so many such things. I think all our students are very blessed now, sir, with your presence.
Thank you, sir. Thank you. I'm honored.
Presence.
Yes, sir.
And he is popularizing actually the Quantum Nation book. So many translations, even this book was translated into Telugu also. I think you might be aware of this. And you can follow his videos, you can follow his podcast, because he is a main campaigner of Quantum Nation across the world. You can follow Dr. L. Venkat Subramanian Garu. He is not only a technocrat, he is more of a humanistic, and he is very student friendly. Wherever go, he discusses with students. Wherever go, he moves around the students. And his focus is making our state is also a quantum state. Now he is traveling with our IBM quantum mission. He is now going to meet our Honorable CM, who is also there at Delhi. Sir, kindly convey our CM Garu, Honorable CM Garu, about this boot camps, because around 50,000 young
Yes, sir.
students are there. And we promised them to whoever who excel in this hackathon, they will be provided with internships. Even IBM is also offering, even Google is offering, so many companies, even the startups like T-Krish is offering. So here it is a Telugu version of Quantum Nation. This is translated to so many languages. You can also take this from Amazon. It is only 100 rupees, I think. This is, sir, it is a great moment for all our students. Kindly,
you.
the floor is open for you. Kindly give some inspiring words.
Thank you, sir. Actually, Anil sir has been a driving force. And I must tell you that this is probably the biggest hackathon in the world in quantum. I have not seen a hackathon which has 20,000 participants. Okay. So which also means that you are being given a beautiful, huge opportunity here. People who will do, in fact, we are here right now. I'm in Delhi. I live in Delhi. And today the CM and his team have come. And one of the things they are discussing is those who do well in this hackathon, how can they be given bigger chances? How can they be given better opportunities to solve even tougher problems? And you will become famous, I'm telling you, whoever does well in this hackathon. So you are getting a beautiful opportunity here. As sir has mentioned, there will be prizes, you will get internships, but the point is you have to work very hard, so use the boot camp that is there happening now. For example, Rishikesh, Rakesh, and the earlier speakers. Ask lots and lots of questions. Make sure that at the end of this, whether you win or not, you have learned quantum and prepared yourself, because you have to be an early mover. You're getting an opportunity which very few people in the world get. So use this opportunity, become a leader, come out as somebody who is going to change the world. You're going to get 10 problems now, but if you do well, you will get more opportunities for internships, working with the state government. So please, reach out, utilize this opportunity the best way you can, and all the best to all of you. So thank you so much for participating. So I'm glad to see, such large numbers. Make it successful, make it a great learning experience for yourself. Thank you so much.
Sir, may I request any students, any 2 or 3 students can interact with, can pose a question to the greatest man here. Sir, just 5 minutes.
Yes,
I know you are very busy.
Yes.
Any colleges, any students can interact with it. It is a great opportunity for us. Please raise your hand.
So, yeah, so while you are all asking, thinking about asking questions, I also want you to think about, today, you all work on your laptop, your mobile phone, which is a classical computer, zeros and ones, bits. Now, for the first time through this hackathon, you are getting an opportunity to work on a very different kind of computer, the quantum computer, which does not use bits, but it uses qubits. Okay. So which means there is some learning, you have to do. You have to put some hard work, you have to put some effort and learn about what you are doing here. But I can assure you, once that learning happens, the kind of opportunities you are going to get are going to be amazing. So please use this opportunity. Don't be shy. Ask whatever random questions. You are allowed to ask anything you want. If you don't want to ask here, send a mail, send a message, whatever, not only to me, send to sir, send to Rishikesh, send to Rakesh, or anybody, in fact, ask until you are very clear about what you want to do, about the future of yourself, about the future contributions you'll make in quantum.
Government act and making. Lagging case of
Dear students, any questions from your side? You won't get this opportunity again and again. Any college from Dhanikula or
Okay.
Yes, that is SAR's book, Quantum Nation. Actually, recently, sir, you have gifted to our college people. It is from our college. Thank you, Narayan Garu. And one more opportunity, you're really, sir.
Thank you, sir. Thank you.
Thank you, sir. And one more opportunity our students are getting. Dr. J.B. Reddy is also going to connect. He is actually NQM.
Very nice. Excellent.
National Quantum Mission head, who is heading India. So this is the opportunity, students, dear students, you can interact with great personalities like Dr. L. Subramanian Garu, and now who is going to connect with us, Dr. J.B. Reddy Garu. He is actually heading this mission. Narayan Garu, please check ఒకవేళ J.B. Reddy Garu వస్తే connect చేయండి. Any students from Aditya or KL University or Dhanekula or Gayatri Vijaya Parishad?
Sir, can I ask a question, sir?
Yeah, please.
Sir, how quantum computing is working on social sciences, sir? So it is purely science-based working, but how does it works for social science?
See, sir, any, as a computer, any computer will, you have to take your problem. So whether it is in social science, social science, you could look at demographics, what kind of demographics are, capable of or working in certain areas or whatever. So I think what you need to do is take that data and see what kind of, analytics you want to do with it. Okay. So in fact, social science use cases are very good use cases, which you can, but the people who work on a computer are the computer science or the programmers. So that interface between social science and computer science needs to happen. You need to sit with some student who is looking at who knows how to, for example, program a quantum computer. It could be Rishi, it could be one of any students who is participating here. You take any social science problem and then cast it as a problem which you want solved. What are the problems that you are looking at? Is it some demographic problem? Is it in terms of some social justice? What are the factors there? So any of that has to be reduced to a problem which can run on a computer. So I think this is a very good question, which is saying that, two different sets of people, interdisciplinary people need to start talking to each other so that we can, solve some of these problems. Because, as a computer science person, I might not know what are the problems in social science. You as a social science person might not know what I can solve as a computer science person. But if you and I get together maybe for a 1 hour meeting, I'm sure we can come out with something very useful.
Yeah, thank you, sir. And sir, J.B. Reddy sir are also connected, sir.
Good evening. Namaste, Andy. Namaste.
Yeah, sir, just I want to introduce you to students. Sir, there are around 20,000 students across India.
Okay.
So, dear students, it's a rarest of the rare opportunity where the stalwarts, who is heading the National Quantum Mission is here. He is Dr. J.B. Reddy Garu. He is very workaholic and working round the clock, even in he is sacrificing his holidays both Saturday and Sunday. He is traveling across India for establishing this Quantum Valley. And Amaravati Quantum Valley also he is working very hard. So thank you very much, sir. With his support, AP could get so many algorithm projects and so many labs, QT labs. And also, sir is supporting for faculty development program as well as this hackathon also. Sir, simultaneously, we are training 1,000 faculty across our state. And now we are training, going to train 20,000 students. And these are the highly motivated students who are committed for submit something to this Amaravati Quantum Valley. Now the floor is open, sir. You can address the students, participants.
Yeah, thank you very much, sir. I would like to congratulate AP state government under the chairmanship of Madhumurthy Garu and Anil Garu, and wonderful initiative. And National Quantum Mission is supporting all these activities across India. And also, my dear students, it's a great opportunity for all of us. We can become a world leader. India can become a world leader. You are the pillars for the country. I would like to thank for your time and initiatives and everything. All the best, all of you. Thank you very much.
Thank you, sir. Thank you for joining within this short notice. Definitely, your blessings will be there for all our students. Definitely, they will crack this quantum technology. Thank you very much, sir, for joining us. In spite of this busy schedule, they have a meeting with our Honorable CM now, both Dr. Venkata Garu and JB Reddy Garu. Thank you very much, sir.
Thank you, sir. Thank you.
Thank
I'm leaving, sir, if you don't mind. Thank you very much.
Yeah, thank you.
Thank you, my dear students. Thank you all of you.
Thank you, sir. Thank you.
Sir, one question from KU, sir, to JB, sir.
Oh, sorry, he is very busy, sir. Now, okay, you can take. Sir,
Yes,
please introduce yourself first.
Yeah, this is Balabhaskar from KU University. I am a mentor for the students, sir.
Okay.
I want your suggestions for that because after the hackathon, they want to do any startup support for this so that they can do any kind of improvement in the quantum computing, and as a field we can set up with AMARAVATHI Quantum Valley, interact with our campus. That is my question, sir.
Okay. What do you want a funding from the National Quantum Mission? Am I right? As per my understanding,
Yes,
right?
Startup
Yes.
Any funding?
Yes. Actually, National Quantum Mission developed a guidelines to support this startup. It is very important for the country, and we have a rolling call. You can submit the proposal at any point of time. We don't have any deadline to support. We are open to that, and we are supporting National Quantum Mission.
Sir, just adding to this, how much we have to get funding? That is
No limit. No limit.
No limit.
Whatever you want, you can get it if the proposal is good. That is the reason we specially designed the guidelines. Till now, in Government of India, we are supporting about 50 lakh or 1 crore. There is a limit is there. Now, DST created a different guidelines because it is a quantum is a new area, nascent stage. No one is ready to support. That is the reason government has taken initiative to support the startups.
Thank you, sir.
Thank you. Thank you. Thank you. All the best, all of you.
Thank you, sir. Thank you very much. Thank you. Thank you, sir. Thank you, Dr. Venkat, sir, Venkat Subramanian, sir. I also thank you, all the resource persons, Rakesh ji, Rishikesh ji, and Yasser ji, for your valuable support and doing all the problem statements and giving solutions. And you are also giving the platforms and some notebooks also for all the participants. And definitely we will take. We will invite you to this final program also as a jury and also to evaluate all these projects. Dear students, don't think that these are very easy and these are very everybody will be selected. No, not like that. But everybody will get the participation certificate. We encourage to learn more and more on this quantum by the end of the December. At least even our Amaravati Valley requires at least 30 to 50,000 students who can work on this. So this is the actual backdrop of organizing these boot camps and hackathons to create an awareness among all of you. This is an entirely new field, and you are the first persons to choose this in the field. My suggestion for this SPOCs across India, some of the SPOCs till not submitted the student teams details in our portal. And from today evening, we are also enabling another Google form for the submission of ideas. So please submit your ideas as per the template and convert that template PPT into PDF, and please submit all these idea statements in this Google form in the PDF form. And please coordinate with your respective regional center SPOCs who are going to conduct a semi-final round. Once again, for your convenience, I will read out the names and their mobile numbers. Please note down. Regarding this Gayatri Vidya Parishad College of Engineering, Visakhapatnam, It covers 3 districts, Srikakulam, Vijayanagaram, and Visakhapatnam. Dr. Anuradha will be the SPOC, and you can, these districts people, they can note down, and her number 888-64-77792. I will read out again, 888-64-77792. She is the SPOC, and you can coordinate. And I request Dr. Anuradha madam, would you like to say something about your participants, your SPOCs across your 3 districts? And coming to another SPOC, SRKR Engineering College, Bhimavaram, Dr. P. Ravikiran Verma. He is dealing with East Godavari and West Godavari. His number is 9494464651. 9494464651. And coming to the Dhanekala Institute of Engineering and Technology, Dr. Madhukant Ravi Garu is SPOC. His number is 9247382963. 9247382963. Coming to JNTU Anantapuram, Professor A. Shobhabindu madam is there. She is covering almost Anantapuram and Kurnool. Her number is 9391452668. Sorry, 9391452668. And coming to Sri Padmavati Mahila Vishwavidyalaya, Dr. J. Suryakumar is the SPOC. His number is 80560222121. Here it is the covering districts are Nellore, Chittoor, and Kadapa. Yes. So these are their contact numbers. Please coordinate with them. I thank all the regional center SPOCs, their principals, because they are sponsoring this semi-final round. And I thank all the mentors and SPOCs across India who are really working on this quantum technology and quantum computing. And there are people today in the afternoon session. There are 4 resource persons all together are there. All these 4 people will help you at any point of time. So they are also helping us in as a jury members during our semi-final round as well as the final round. So be passionate, be connected, and your college mentors, your college faculty are the best persons to give any type of clarifications on this. There are so many platforms, online platforms are available. Even IBM Cloud is available. IBM Cloud Learning is available. IBM Cloud ecosystem is available. And Google Cloud is also available. You can make utilize of these all things. So don't go for hardware, purchase of hardware. We won't suggest you because it is very costly. For a student, we are not advising. You can use all these platforms online. Okay, finally, on behalf of APSHE, here Professor Vishnu, please, all the best, sir. All the best. Please come. Vishnu Mohan Garu is the senior faculty member, senior professor from Kakatiya University. He is actually a mechanical engineer who is rightly connected with this quantum computing, quantum technology. He wants to say a few things and wishes to you.
Good evening. So I congratulate all the students and to make use of this opportunity, because this kind of opportunities will come very rarely, and please prove yourselves by your achievements. So one advice I would like to give, please document everything, every step of your work, and also if it is practical or whatever it may be, and the dates. Yesterday, as Mr. Mauligar was telling, that is very important, because these things will lead to, if you want to apply for any patent, this will be useful, because you also please learn about how to patenting methods and what is the methodology for patenting. So this will help you in getting your own patents, and finally you can bring out your product or whatever you can. So financially you can benefit from these steps. So this is my advice to all the young budding engineers or graduates. So thank you very much for giving this opportunity and all the best for future endeavors. Thank you.
Dear student friends, on behalf of APSHE, Chairman Professor K. Madhumurthy Garu, actually he want to join now, but due to busy schedule, it could not happen. He is in another meeting. He want to tell you something that you will be given a participation certificate, and those who are qualifying in this semi-final round, most of the candidate will be connected with the startups or some industry on quantum. They will be provided internships, free internships. And if you excel in that internship, those companies and startups will absorb you. They definitely. As you all listen that Dr. J.B. Reddy Garu telling that the funding, there is no limit for funding. So whoever coming with the use cases, they will be funded some lakhs of rupees, and you can become entrepreneur. It is our honorable CM's vision. Every household to become an entrepreneur, at least produce one entrepreneur. So these startups will be a game-changing under this quantum nation mission, and try to establish your own startups with these initiatives. So our aim is after the completion of the final hackathon, it should be the finalist, at least the finalist should come with a use case. So this is our ultimate goal, so that most of the students who are developing in this quantum technology movement will be getting jobs. There is no limit. Once again, I thank you all friends across India, our mentors, our sparks, and today's resource persons. Thank you very much, sir. Sir, Rishikesh ji, are you there?
Yes.
Sir, kindly you can conclude with your concluding remarks, and kindly share the this information, sir, so that you can share.
Yeah.
Kindly conclude with your remark,
your
concluding remarks, sir.
Yeah. So, as Venkat sir said, then Reddy sir said, quantum is going to revolutionize this field, our day-to-day lives. So right now, as I mentioned in my talk, it is in NIST, and you are the guys. We all are the guys who will shape it. In the civil progressing days, we are the guys after you graduate, will take these jobs, and you will be the person who will be, reaching to the limit of this, what we can say, crossing the area of NIST and getting those problems solved, which are unthinkable. What we can say, building secure systems for banks and strengthening the nations and doing all the work. Okay, so this is very interesting area of interest. Even don't think like if you're not able to understand or something like that, try to now there are these tools, GPTs and all. You can just try to understand the concept if you're not understanding by your teacher or you're not understanding through any courses. I shared a course link in the chat. You can refer to that as well, and you can refer to Prabha Mandam's course on NPTEL of IIT Madras. So, try to understand the concept, and more than understanding, try to implement it. Whenever you are trying to understand, okay, this is, superposition. Let me try it from my side. Okay. Adding just, like certifications and everything in your resume will not help you. Okay. What will help you is projects and understanding of that. Even when you go to company, they'll ask what project you have done and they'll ask to describe you. And these projects only become use cases, which are useful for startups, which are useful for industries, which are useful for anyone. Okay. So let's say, for example, I think there is a problem of fraud. Okay. So if you solve that problem, banks will become more secure. There will be no loss of money or less loss of money. Okay. So these are really, there is a lot of scope, and you can do a lot, you can explore a lot. And this hackathon is really a great initiative to explore about quantum and its applications. So yeah, you can connect me on LinkedIn as well. You can ask me any questions. And thank you, Apshi, once again for inviting us along. And yeah, we'll share these materials with you shortly, and you can forward it to all participants, and they can refer to it. Thank you, everyone. Thank you.
Thank you, sir. One request from my side, kindly all the SPOCs, please share, please publish all these 2 days initiatives of bootcamp in local newspapers and telemedia and also social media. And also share the YouTube link to all the students, even your friends who are not attending this, so that it can help them to learn something about quantum technologies. So with these few words, I thank you all and I appreciate the students and wishing you all the very best in the future quantum entanglement. Thank you all. Thank you, sir. Thank you, everybody.
Thank you, sir.
Thank you, sir, Rakesh ji and Yashwar ji.
Thank you, sir. Thank you.
Thank you, sir.
Shall I close the session, sir?
Yes, sir. Yes. Thank you, Narayan Garu. Thank you very much for providing your Zoom link. Thank you.